Um, Ravi Kiran sir, shall we check whether the PPT is working out? Can you please share your PPT, sir?
Okay, so I cannot able to share my PPT.
Okay, I will
December.
ask. Yes, yes. Once again, sir.
How I can able to share it? Just
Uh, yes, yes, sir. It's visible now.
you're able to see my right? Okay.
Yes, 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 sir. It's visible, sir. Shall we start the session, sir? I will give introduction. Predicting the future isn't magic, it's artificial intelligence by Dave Waters. Good morning, everyone. My sincere greeting to the participant who has joined for the final day of 13th session of online FDP program sponsored by AICTE Training and Learning on Data Science and Artificial Intelligence in Chemical Engineering, Recent Trends and Future Outlook, organized by MBJ College of Engineering, Department of Chemical Engineering, in association with IAC and IQAC. Today we have our most eminent resource person, Mr. Ravi Kiran, Senior Professor in the Senior Process Engineer in R&D from Grace Division Chemical India Private Limited, Chennai. So let me brief some key credentials of his achievements. Prior to joining in Grace, Sir was associated with Tata Research Development and Design Center, Pune from 2011 to 14. Sir has completed his post-graduation in chemical engineering from IIT Madras. So strengthen his specialization in modeling and simulation of geochemical system with sound knowledge of fluid flow, heat transfer, thermodynamics, chemical kinetics, numerical methods, developing computer codes and analysis of stimulation results, identification bottlenecks, supply chain management, data analysis, and visualization. And so also had an experience in mathematical modeling using various software like MATLAB, C, and Fortran since last 11 years. And he also have 11 plus years of experience in Aspen Plus and 8 plus years experience in CFD. Sir has awarded Saraswati Memorial Award with silver medal for the best project in the area of environmental engineer in IIT Madras 2011. Sir also has received the On the Spot Award for Outstanding Contribution to the organization, Data Research Development and Design Center, ITCS Innovative Labs in the year 2014 and 13. And Sir has also received the Outstanding Paper Award in the year 2013 from TCS. So with a very short note, I would like to invite Mr. Ravi Kiran sir to deliver his talk on predicting right feed mix to control the product quality based on predictive analysis. So predictive analytics. We welcome you to the FTP platform, sir.
thank you so much for introducing me with a brief introduction. It's once again very thanks. Thank you so much.
Thank you, sir.
And good morning to all. It's early morning. I don't. I think you all busy. I mean, you might have tied up with a lot of sections last 4 days. And let me have the section as a more interactive section. So rather talking about the presentation, I mean the topic, real topic. Let us discuss some of the algorithms available and look at how those algorithms can be implemented in the, any kind of software. I'm right now I'm using MATLAB for for solving one such algorithm here. But please stop me whenever you have any questions, and we can discuss that before we move on to the next slides. Okay. And also, I'm keeping off my video so that network bandwidth can control. So now the training and also the topic is related to the data and data science. So let's look. I hope this slide you might have seen so many times from the so many resources, including the social networks. But let me tell you the data analytics, even if it says promising or interesting for the software people, but this analysis part has been done for various kinds of industries, all the way starting from chemical industries to retail industries or any logistics calculations. For example, if we see if we go to any shopping mall, so they also do some kind of analytics to estimate what type of items or assets they are typically the people are viewing and buying it. So try to repeat them as much as possible to have more business. Similarly, if you see similar kind of analytics has been done for any industries to estimate, uh, identify the bottlenecks, identify the logistics issues, or identify fault detections where plant might have down for some time due to the various reasons. So, if we can able to identify them upfront, then that will be very help uh, for the industry as well as the for the people who are working in industry to gain more in terms of business revenue. So this data analytics may be directly with the trends. Sometimes the analytical may be with respect to the text. So sometimes we may have, uh, uh, I mean, maybe continuous series. We may have continuous series, or we may have category series, which is like zeros and ones, or on and off. So such kind of analysis also can be done using data analytics to predict some kind of risks, operational analysis, retail analysis, or manufacturing supply chain analysis. So most of this data analytics, a lot of software people are basically they are doing for using NLP program, but this analytics can be applied for real industries as well. So even the Titus is a chemical industry, but it can be applied for. You can see automotive industries also can be used to. We can apply this data analytics to automotive industries as well as the aeronautics. Also, we can see the logistics. We can also apply for the healthcare. There are huge innovations are happening related to the healthcare. Basically, how can we utilize the graph that we have? If, for example, if you go to any hospital, right? So they have the historian of the heartbeats and some kind of testing medical devices using some medical devices. Right? So using that medical devices, can we able to correlate of the patient status by using only data, not with any kind of testing part. So there are a lot of industries are working towards applying the analytical techniques also along with the machine learning algorithms sometimes if needed, and provide the solutions much upfront and much quicker to the patients if it is healthcare, or to the industry for the any chemical or mechanical or any industries, or to the retail shop on the improving their businesses and so and so. And typically the data analysis or the machine algorithm, they have some kind of workflow needs to be planned or prepared. So this structure is always mandatory for them to get a proper align the data with respect to the real phenomena that is happening statistically. So if you get here on the top picture left hand side, typically we'll get the data in terms of Excel files or in kind of some from in the form of text or CSVs or whatever it may be, but those data are coming from historians basically. So if it is a chemical industries or any kind of industries, they have their control historian systems which stores the time series data for the response of the each unit of occurrence from the sensors. So that is the data that we able to get from the plant team. And once we have the data, then we try to plot them. It could be a scatter plot, or it could be contrast plots, or it could be kind of classifications or clustering. So those kind of we need to prepare, pre-process the data what we have and identify which are data is qualified data, which are data is not qualified data, and sometimes we may need to eliminate outliers to get a smoothened data to better understanding it. Once we have prepared a smooth data by analyzing the data from the historian database, then we try to start developing miscellaneous algorithms to understand the effect of parameters on the performances. So once you develop a model, then we can use optimizations for the continuous signals, or we can also develop kind of classification models to classify the problem with respect to the physics or objective. Then there is a once we develop a model, it could be like kind of scale up, then integrate the model with respect to the any kind of software to the back to the plant team or back to the any kind of industries using some various tools. So if you look at overallly, what typically we do is that we collect the data, translate the data into understandable data format, then use any machine learning algorithms, and once we develop a model, that model can be shared to the various levels of employees or within the organization, and utilize that model and scale up that model if it is needed, and use the model for improving their process or industries. So the typical the blocks should like look like this way. If you look at it here, so for example, I'm the one who analyze the model and develop the model using machine learning algorithms. That model can be shared with any number of people, and that this model it's active while you're walking. I mean, no need of going to the plant. For example, I'm sitting here and right now, like during COVID, right? So it's very hard to go to the office and collect the data and stay at the plant because of the safety constraints. So if you have this kind of models in upfront and have developed in digitally, then we can able to see the live data in a digitally manner itself and identify whether my plant is working fine or plant is down. So that can be seen at any point of time. And the same in the first top picture is repeated here, and the all the steps in the analytical aspects should continuously consecutively repeated to get a better solutions. And any industries basically they do basically for chemical industries, uh, it is not required to have clustering models, but mostly it will have in terms of classifications and also regressions. So for chemical industries, major models will be supervisor models. I hope you might know about types of models available in the machine learning algorithms, but I'll introduce all the models in the next slides. But for chemical industries or any process industries, major of the machine learning algorithm or areas in the machine learning algorithm will be only in supervised learning algorithms, such as classification and regressions. So these two are major models that required for the industries. So when it comes to machine learning algorithms, there are um, basically there are three types of different machine learning algorithms are available. One is the supervised learning. Second one is the unsupervised learning. Third one is the reinforcement learning. Some people might have called reinforcement learning into the unsupervised, but I just want to separate them due to the fundamental that is happening within the process. So I hope this you know already since last 4 days. You might have a lot of people might have prepared the slides, but here is some kind of tree which can help us to have what kind of models are available within each category and within the each subcategory divisions. So under supervised learning, there are two more models which is called as regression and classifications. Uh, so the term itself is you can able to understand regression is a regressing, developing a regression model, which is the developing a correlation between the input versus output. Classification is like classifying the data in terms of various groups. For example, the example of the regression will be like uh, finding out the rain, or if you look at the atmosphere, right? So it continuously, if during the raining period, you can able to try to identify the wind speed with respect to the time, and also using that we can able to predict how whether rain can come or not in the next coming couple of hours or couple of minutes. So that we sometimes we call it as a regression models. But in terms of classification, for example, that classification can be male and female. So if you have some hundred number of group of students in the school or class, how many number of girls are there, how many number of boys were there, and their names. So that could be like kind of classifications models. And within the subdivision of the regression classification, there are again few more models are available. I have mostly I have covered all the models here, but maybe I may miss some models, but most of them are covered here. I'm not going to explain each and every models in detail, but at least I'll take the linear regression model uh, to demonstrate, and also I try to use MATLAB to solve the linear regression models. But this slide might very useful for you to have at least an idea what kind of models are available with respect to the each learning algorithms. And coming to the unsupervised algorithm, basically those are called as clustering algorithms. So you can see there are 8 different types of models are available for unsupervised learning. So is there any questions before we move on to the least square method minimization for regression models?
Participants, do you have any queries on this? Sir, we can go ahead, sir.
Okay, thank you. So the wording itself called as at least minimize the square root of the error between predicted versus the actual values. So let's take how I don't want to discuss more and more deeper into the physics, but let me explain you at least background of the methodology what we have. Okay. So you might have used this model since long back. Maybe during your bachelor's degree, first and second year, also you might have this course to estimate or to fit the curve or fit the line based on the data that you have. The similar kind of concept will be here. So, so for example, let's say you have a straight line that you want to fit f of x equal to ax plus b, and which has one output variable and one input variable. So this is a single variant models, and and as I said, the we are trying to minimize the error between predicted versus the actual value. So that is we call it as a d. So y is the actual value and f of x is the predicted value using these correlations. So we need to minimize this error, some of the square error here for all the points what we have. And for example, if let's take we have a 4 data points. So we need to calculate each data point as error square and sum it up for getting a error if you use a function of f of x equal to ax plus b. And this is finally this if you have n number of points, the summation can be converted into summation formula format. You can see here f of x equal, I mean this error equal to summation of I equal to 1 to n yi minus f of xi whole square. And in the place of f of xi, I can place the value of ax plus b. So that was here. Now, as I said, we need to minimize the error, identify the coefficients of a and b, where I can able to see the this error becoming very minimal. So minimal should be, ideally it should be 0, but typically we will not get a 0 error. There could be at least some positive or negative error could be there. Basically, this will be positive error because it's a sum square. So now the objective function will be converted into minimize this error. So I hope you might have during your intermediate or +2 class or the BTech, you might have seen if you want to minimize any function, then you typically what we do is that we try to take the derivative of the function, and that derivative should be equal to 0. Then we're able to see the function, the minimum value, and whether either minimum or maximum. So to find whether it's a minimum or maximum, we will try to do second order derivative and see the second order derivative should be positive for maximum and negative for the minimum. So here, what we do is that we try to take derivative of the function with respect to a and b, because those two are our variables, and x is already known data series and y will be also known data series. So to identify a and b, we need to take derivative of this function with respect to a and with respect to b. When we take a derivative of a, we'll be able to see this function. For b, it will be this function. So, and when I write these functions together, it will come like, if I take -2 here, eliminate them and simplify them, and we'll able to see this kind of linear equations that can be obtained for by solving about two equations. Now ax plus linear equations, which where we have xi is already known variables, b are the coefficients, uh, and n is the number of points in the system. So we can directly solve and identify a and b by taking the uh, uh, summations or eliminations or subtracting one equation from other. So you'll be able to see uh, a and b are in this format. So you can physically you can solve, or you can convert them into matrix format, because a and b are coefficients, and you have the equations, linear equations, algebra linear equations, and you just simply convert into matrix and take matrix inverse method to calculate a and b function values of the function. So this is very simple for a single linear equations, uh, or to estimate, identify the coefficients of a and b if you are trying to fit an equation of y equal to mx, ax plus b. So what we have seen is for first order single variant model, but if you have an nth order of single variant model, so the same methodology can be applied. What we did here, same methodology can be applied, and it can be derived. We can also derive what could be the coefficients of A0, A1, A2, A3, and so on based on the matrix inverse method. So if you write the same equations for all the variable, you're able to see this kind of matrix for A and B, and by using A inverse B, you'll able to get the small A0, A1, A2, A3 for the model fitting or coefficients of the mth order polynomial equations. Now, when you try to fit this equation, we need to be very careful, uh, because see, uh, you might have remember your matrix calculations, right? So if you want to get a good solution of the any algebraic equations, the main thing that we need to look at here is that the rank of the A should be equal to the number of variables. That's the first line we have to look at. If the rank of the A is less than the number of variables, then we'll be able to get a trivial solution. If the rank of A is greater than the number of variables, we'll be able to get a trivial solutions or multiple solutions. So so we need to look at while you formulating this formula, capital A or capital B, we have to be very careful in formulating it, because if you miss something, if you did some error, definitely you will able to end up with the wrong results. So once you fit in a model, there are multiple categories that we need to get, whether whatever we fit the equation is correct, it's a good fit, or how this fitted model will respond for the future calculations. So that is, we call it as a correlation coefficients. So basically, correlation coefficients are calculated based on the uh, root square error what we receive, and also, as I said in the previously, whether we are fitting over or under based on the trends that we have, based on the data points that we have, and also based on the variables that we have. So sometimes we may have very less data points, but we are over committing and try to fit higher number of order equation to minimize the to improve the correlation coefficients. But we have to be very careful while you are deciding the orderness of the polynomial equations. So how to here I just presented how to calculate uh, regression correlation coefficient through the model. So I think just let's directly go to the formula how we can typically calculate correlation coefficients. So this is the function where you can calculate correlation coefficients. And if you try to use Excel part to correlate the regression model, Excel is automatically going to calculate the correlation coefficient that is called R square. So R square will be the square of this right hand side function. And this correlation coefficient, I hope you might understood based on the statistics course, the correlation coefficient will give you the information how well that variable is correlated with respect to the output variable. For example, you have A and B variables. One is maybe A and B are independent variable, and you want to see whether A and B correlated each other. So if you want to find out, so you can calculate correlation matrix between A and B. That correlation matrix will tell you whether A and B correlated or not. So if correlation between A and B were zero, value was zero, that means that they were nowhere correlated. If it is plus one correlation value, that means that A and B are strongly correlated in a positive direction. If A and B correlation value between A and B are negative one, that means that it was strongly correlated in a negative direction. So positive direction in the sense when A is increasing, B always increases, or vice versa. It's strongly negative correlated in the sense when A is increasing, B decreasing it, or vice versa. So that can be answered using the correlation coefficients here. I hope, is it clear or any doubts on the methodology of the least square method? And this method you might have seen many times while you're I mean during your undergraduate or intermediate classes. Any questions as of now?
No, sir, we didn't receive anything in chat box.
Okay.
Uh,
Okay.
we can go ahead, sir.
Thank you. So let's start with some examples how we can utilize this model. Okay. And I'll try to write them in the MATLAB. I hope you might have seen MATLAB software maybe during your classes, but the same kind of algorithm can be utilized in any kind of language. It could be in Python or it could be in C or Fortran or anything. But here I choose MATLAB because I'm much more familiar with MATLAB and it's pretty easy and it's a very good user-friendly software to solve it. So the example here is that we have a X data and Y data. By looking at the data itself, we can able to say it could be. Can anyone say what is a? I mean, which order it could be when we try to correlate Y equal to X? Is it in first order, second order, third order, fourth order? Based on the data. When X equal to 1, Y equal to 1. When X equal to 2, Y equal to 4. When x equal to 3, it is 9, and x equal to 4, but it's 16. So it means that y is equal to x square, right? By looking at the data. So that we are, by looking at that, we can able to see the relation between them, how it was related or correlated. But let's start kind of dumb people where we don't know about the relation, and we have XY plot, and stars are the actual data. And I want to fit an equation linearly and see whether my linear equation is fitting very good or not. Okay. So that is basic idea to start with here. And there are multiple ways to solve this problem in a MATLAB itself. There could be more than 10 to 12 different methods, but I typically use 4 here and demonstrate how can we write these 4 different methods, and when can we use this method for which kind of problems. Once we finish this 4 or 5 different training examples, then I'll move on to the topic of the today's discussions. So let's start with programming in MATLAB. So I just want to divide my screen into 2 different parts. One is for the program and one is for the slide. So typically when you open the MATLAB, it should look like this. So this is we called as a command window. Then we can see the current folder, and this is also workspace. And we can write the program in the command window. So that could be possible, but I prefer to write a script where we can save the script file alone. So when you click this new button and the script, or you can also directly go script option there. So I'm just open my new script here, and when you write the program, people typically use a CLC. That means clear the screen. Uh, So clear the screen in the sense, for example, if we have something like uh, previous data was or solution was there here, and if you use a CLC either here or the program, before we run the program, it's just clear the command window. Then clear all is another variable that we typically use. I mean, people who are writing the program, they try to use these 2 lines to clear the screen and also clear the all the variables so that I can utilize memory allocations properly for the current program. And so once we write these 2 lines, so I try to write enter the x values here. Sorry, it should be semicolon. And y equal to 1 semicolon 9 semicolon 16. And before we run this program, we just need to save them. So let me save this file somewhere location here. So I've saved this file as example 1. So if we run this problem, so you can able to see in the command window, it is going to write x and y values here. So since you have not closed these lines, I hope you might have experience in Python or C or Fortran, right? So to print it basically in C, we need to write a printf. But here it does not require. If you're not keeping any semicolon in MATLAB, then you will be able to see that value printed in the console. So currently I have not kept any semicolon in the x and y variables, and here it directly write it. So for example, if I make a semicolon here, and if you run it here, it does not write anything in the command window because we closed and we informed to program that it should not print. And one more important information here is that we no need to declare here. So automatically the x and y, if you specify value, it automatically take care of it. So if you want to see what kind of class of x and y, just need to write class of x. You're able to see default value of the class of x is a double. We can always change the class before we assign the variables, but here the default value will be double. So now we have x and y data entered, and if you want to see the plot, you just need to type the plot command here, plot x and y. So you'll be able to see continuous curve when you run here. So sorry, it is one. So it is a continuous curve. But if you want to plot as a scattered plot, you can just type scatter. Then you will see scattered plot with the circles, or you can also change instead of circle, you can also change into stars. So very friendly tool to utilize to use it, uh, but people, different people might have different opinion to different software. So now once you have x and y, and you just plot it and see how the values are with respect to x and y. So let's go on to the writing this method one, where what we have seen in the previous is the least square minimization method, and we already seen what is equation for a and b when we have first order polynomial equation. So these functions are already known. So let us calculate a and b. So if you remember a previous slide, or here I have already specified the formula. So it is like summation of 1 to n uh, and xi and yi. So we need to multiply each element in x and y, multiply together and have it. So either you can have typical what we write in so program way back ago, right? We try to run the for loop. Uh, 1:1 length. Here is 4, right? So we can write 4, and we can all we can write for loop to calculate multiplication of these two. But here in MATLAB, there is a straightforward multiplications. So that we say is that x dot star y. What it does is that when we have a dot in the sense, element by element, just multiply and have the function value. So let's see, for example, the this if you multiply element by element, it should have 1, 8, 8, 27, and 64, right? So if I run this command here, right, x dot y star y, we should be able to see that value here, 1, 8, 27, 64. So already element by element multiplication is already done. So no need of running a for loop here to to multiply each element in two different lines, right? Two different vector. So it's a very straightforward. If you have hundreds or thousands of uh, elements within the same vector, imagine it takes huge amount of time to compute it. But when we have this kind of simple line program, it's only one line to execute it. It's much faster. And once we multiply them, we need to take sum. And typically in C or Fortran, we try to write summations, but uh, Python has subroutines to calculate the summation of the any vector, and also MATLAB has it. So the sum is the function where it does the summation. So if you want to see what functions are available here for the summation, just you need to write help sum. So it gives you the background information of the what sum means. Sum is the summation of all the elements in a single vector. So I just gave this. So when you write this, what is that? It is going to sum 1 plus 8 plus 27 plus 64. So you can see that value here. So that is the 100 is a number. So that first term is done, and you need to have n number of points. So number of points are equivalent to the length of the vector. So I can take length of x. So it gives us the first term in the numerator. So let's prepare this. So we have done with the first term, and second term is summation of x multiplied the summation of y. So we already seen the calculation of the summation. So we did the numerical term, and denominator term we need to write it here. So in the denominator, we need to be very careful when we brackets closing and opening because the each operator has this order, right? So slash will be first, multiplication second, plus and minus the third options. So we have to be very careful before we applying the slash, because if you are not properly closed, the slash will be applied to second term of the numerator, or so that should be very careful. I think this kind of things you might have aware of that during your courseworks. So in the bottom you can see length of x, that is the number of points, uh, multiplied by uh, x square, summation of x square. So just write sum of x dot power 2. So what it does is that it takes the power of x square, and that means that each element square I'm trying to take. So that is my first term in the bottom, and then it's a minus of summation of x whole square. So sum of x whole square. So let's close this also and apply all of those. So this term is a, right? So based on the formula, it's a equal to this. And next term will be b equal to sum of y and sum of x square. So sum of y multiplied by sum of x dot power 2. So that's just x square. So that is sum here. And second term will be sum of x and sum of xy. So the sum of x multiplied by sum of x dot star y. So this is the numerator part. Denominator is the same. So just let me copy paste here. By the way, how many of you are familiar with MATLAB? Okay, I hope. So we entered these formulas in MATLAB, which is pretty simple and straightforward. And when we ran the model, you can able to see the solution of a equal to 5 and b equal to minus 5. So for this data, what we have, and we're trying to fit y equal to mx plus b, mx plus c, or ax plus b, and what model was predicted is that it's 5x plus b, 5x minus 5 are giving good predictions. But you just see at x equal to 1, the 5 minus 5 equal to 0, that means y should be 0, but y equal to 1. When x equal to 2, that means the 5 into 2 is 10 minus 5, which should be 5, but here is 4. 3, that means 15 minus 5 is a 10, but it's 9. So there is a error when we try to fit the x and y in a linear manner. So there is an error, right? Blindly we're going with mx plus c, but we may need to do a polynomial functions in the later stage. So whenever you try to develop a model, we start with a simplified model, that is a simple linear equation, and try to estimate the error and see whether the error is minimum or not. If that is not possible, then move towards the higher order. So even though if it seems to be second order, don't go directly to second order. That's the best way to identify it's a function. Okay, so whenever you do machine learning algorithms, this is one key idea that you need to remember. Any kind of linear equation, start with a simple linear equation, then keep on adding complexity in terms of order or in terms of variables. Such kind of things you need to be very careful. So this is one method that you can able to solve. And second method, for the same problem, for the same linear equation, It's a straightforward. See, we have written these functions, right? These variables. And remembering these functions like a equal to some and b equal to something, right? So those formulas, remembering those formulas might be very tough. There is a simple way to remember for an nth order also. I don't want to say it here, but for anyone to remember those formula will be tough. And MATLAB has another uh, route to calculate it. That is like backslash. So if you use a forward slash, it's a division, and if you use a backward slash, is a um, uh, basically minimization method, least square minimization method. Now, if I want to use a slash, right? So what the background of black slash is that um, how many variables that you are considering, um, those many number of coefficients will come out. For example, if you want to write, if you specify x backslash y, what it does is that it gives you uh, y equal to mx or ax. It's not going to give you b because there is no coefficient at all here. So that is one point that we need to remember. So to get a coefficient like that means constant number in y function, then we need to prepare our x should have the coefficient number. For example, if you want to have y equal to mx plus b, then the x in front of b will be x power 0, that is equal to 1, right? So that we need to provide as a matrix. So let's prepare that. So I hope you try to understand what I'm trying to say. So um, the x terms, if you look at in the right hand side, the power of x in front of a will be 1. The power of x in front of b will be equal to 0. So x power of 0 that we need to write and prepare them as a matrix. So then only we can utilize this back forward functions to calculate the least square minimization method and to fit ax plus b. If you're not calculating, if you're not providing x power of 0 into the matrix, which in the right hand side of this function, that's going to just fit y equal to ax. It's not going to give you b value. So now x power of 0, that is 1, and how many ones needs to be written? So that we need to write for 4 here. So there is a directly you can write b for 1 times, or in MATLAB it's a function called ONS once of how many length, how many columns you need, or how many uh, rows we need that we need to provide. So in once itself there is a length, how many number of rows is needed. So here by number of rows, this is a column vector, so we need to have 4 rows. We can specify 4, or I can write them as a length of x. So if my x length is changes, my number of ones also length changes. And how many number of columns required? I need to have 1 column. So if I copy this and paste it, you will be able to see uh, what it writes. It writes the 1 per 4 rows, which is similar to x. X has a 4 rows in a single column, and ones also have 4 rows in a single column. Now we need to make them as a single matrix. So first one will be x, second one will be y. I mean ones. So that can be done using x space this and use the square brackets. So this is like kind of 2 column vector with the 4 by 2 column matrix. So if just to write here and you can able to see it has a matrix having a 4 rows and 2 columns. So it's a 4 by 2 matrix. Now when we have this, then try straight away apply a backward slash and y and C, try to specify them as a solution to then see what kind of solution we'll able to see. So in previous first method, we were able to see a equal to 5 and b equal to 5 or minus 5. In the second methodology, you can see first term will be a because the variable that we use in the first is x and the variable second we use is a b function. So that's why the first will be a and second will be minus 5. So here it's a very simple single line code. We no need to write formula. And if you have a higher order polynomial equation, it's very tough to get A and B, C. and so on the functions of it, and it could be longer, and it could be very complicated. But we just need to use this function where you can able to resolve much quicker and no need to remember any formulas. So this is the second way of calculating it. On third way, in MATLAB, there is a function called polyfit. Just see what polyfit does. So polyfit is basically it try to correlate x and y and identify the coefficients of the polynomial equations. The polynomial equation can be p of x equal to started from nth order to the zero. That's the constant coefficients. So this is the format it has. Okay, and n is a number of orderness. So it could be, we can specify them. If you're not specifying it, then MATLAB may not know which order that you're trying to solve it. And P will be the coefficients. So by looking at this function, let's start, and we want to use internal algorithms such as a polyfit. X comma y, and order we want to see is a linear equation. That's a one.
हेलो नलीन आने वाली हो ना आज कॉलेज? तो ठीक है बेटा, यदि करना है तो पापा से
So you can see the coefficients of T using third method is 5 and minus 5. So whichever method that you use is the same. You can use the first method, you can use the second method, you can use the third method. It gives the same coefficients. It doesn't changes because all the three are in the least square minimization method. Okay. Let's look at, this is very important because since if you are using a linear equations, we can use any one of the above three methods. But if you have a non-linear method, non-polynomial and non-linear equation, how to use it? So there is a function called LSQ non-linear. So what it does is that solve a non-linear least square problems. So background is a least square method, but this function will be applicable for non-linear. It doesn't mean that we cannot use this function for linear. We can always use this function for linear, but this function will be much more better for non-linear functions. So let's start the same example and see whether this function will help to get a nonlinear function or not. I mean the solution or not, which is same as all the three. So I just started here. First of all, what we have to write here is that we need to write a function. You might know how to write a function called function calling functions. So we need to call this function in the main program and write called function as separate functions, subroutines. So and to utilize this, we need to provide initial guess point. So when we start the initial guess point, then the solution will try to predict towards that by using a iteration methodologies. So let's start. I'm starting with initial guess. If you don't have anything, I'll try to start initial guess value is 0. So now how many number of variables that we have? Those are two variables because it's A and B are the coefficients. So I have to provide two variables as initial guess values. Then I'm trying to call them. Let's say so I am use this function in MATLAB. So algorithm of the nonlinear least square method has been already developed in MATLAB. So we just need to call that algorithm here and pass the arguments to the system. So here my arguments are variables and the input arguments and output arguments. So any kind of MATLAB, if you are using functions, we need to provide. I mean, if you are trying to use algorithms, whatever we develop, whatever available in the MATLAB, to utilize that, we need to provide first thing is that output argument is the first, then input arguments that we have to provide. So my variable will be x. So I'm trying to write here is my x is my variable. So since we have already used x here, so we should not use x. So let me try to change it to x1 is my variable. And I'm trying to write a function name is my function. And here I have x1 comma x comma y. So what it means here is that I have a function which I'm going to write it in my called functions. In that function, my x1 will be variable, which is output variable, and x and y are input argument to the functions. And now use uh, least square nonlinear minimization method to identify my x1 from the starting point as x0. So you start from here and try to do iteration and identify my x1 values. And if we have any kind of bounds like a lower bound or upper bound, so first column will be lower bound. So right now I don't have anything. So if we just specify null vector, and upper bound also don't have anything. And there are other options you can give. You can also modify algorithms to calculate it. Right now I don't want to specify it. So if you see here, so ultimately you can have lower bounds, upper bounds, and options. So I don't want to specify any of them. I don't have anything. Now you already written, sorry, you have already written calling functions. Let's start writing called function in separate subroutine. So I'm trying to write a function here of my function name should be uh, my function. So I just let's copy enter here and paste it. Paste it here. So this should be f equal to my function equal to this and end at this line. So what when you try to save in MATLAB, one thing we need to remember is that when you try to save any function, the file of the function should be same as the function name. If it is different, then MATLAB cannot identify the function. So here my function name is mi function. So I need to save my file as also mi function. Then we need to write each variable function. So I'm trying to how many number of variables I don't know. So I mean how many number of columns we already know that is four elements in the x variables and y variables, but I don't want to make harder here. So I just want to give because later if you want to change 4 to 5 lines, then program should work this program should work without modifying anything. So what it does is I'm trying to create 4 functions that is equal to y equal to there is one y equal to ax plus b, and if I apply the ax plus b, it should be 1 equal to a plus b, 4 equal to 2x plus 2a plus b, 9 equal to 3x plus b, 3a plus b, and 16 equal to 4a plus b, 4a plus b. Yes. So that's the function that I'm writing. So f of k, f equal to, so y of k, so at every element of the variable, I'm trying to correlate them with respect to x1 is my coefficient. So x1 of 1 is my a multiplied by x of k plus x1 of 2. So we provided the function. Now we already called function is also written and calling function is also available. Let's run this and see what is XAA is going to write. So now when you write the fourth methodology, it's going to write whether solution has been found or not. So it says that it found the local minima. So in MATLAB, typically it says the local, it never says the global minima because all the algorithms are local minima optimization methods. If you want to use a global, then there is a different method algorithm that we need to use it. And first A and B are from our first methodology. Solution 2 is from second methodology, P is from our third methodology, and XA is for fourth methodology. You can see all the 4 are giving very good response. I mean, it's the same values. So that indicates that even though we in this function should needs to use only for nonlinear polynomial equation, but we can also use this function for solving a linear equations. So now once you fit this equation, and if you want to calculate, you can always use a and b. But there is a function called polyval. What it does is that it takes the coefficients here and provide the value where you want to find out, and it gives the solution of it. Just forget about that right now. So, is it clear about the methods that are available to solve the simple single equation? There are four methods are giving the same solutions, right? So, is it clear? Any doubts?
Sir, for the previous session, one ma'am have posted in the chat, shall we do this with mini tab? Not for this session, it is like a previous session.
What was the question, ma'am?
Shall we do this with mini tab?
So basically, mini tab can use to do statistics calculations, right? That means that it can be used to analyze the data. It can use to predict the function. But mini tab does not have. I'll give you the example, right? So for example, you have x and y. You can able to use mini tab to correlate y equal to mx plus b. But for example, our chemical problems, right? They are not as straightforward. Let give you an example, right? So if we have example 3 here, right? We have R equal to this formulations. And through mini tab, yes, we can try to use it because background is Excel sheet. We can try to write script, or we can convert the data into required data format and try to fit it. But mini tab can be only useful for statistics equations. I mean, just equations or analysis part. But in the previous section, we have models, physics models. So those models needs to be solved. Did I answer your question,
Yes,
ma'am?
yes, sir, yes, sir.
Okay.
We can carry on with the present slides. Okay.
Okay. Okay.
Thank you very much.
So since there is no question for the first problem, let's look at uh, next couple of things. I don't want to do it in MATLAB now because already you know how to do it. But the solutions are already available in the presentation. I can share this presentation later if you want to try it from our side. So let's see the same equation. We want to fit it, and by looking at the data here, you can able to say a equal to 1, b equal to 0, and c equal to 0. So that should be solution you should be able to observe. And I want to fit this equation using this data. And the same way you can see, and if for the second order equation we need to derive them. So this is not the best approach because we need to derive this ABC coefficients using our hands, right? So this is not the best approach, but second method is the best approach because it does not record anything. You just need to simply provide uh, x square, x and coefficient number, and backslash and give a y. It gives you the A, B, C values. You can see, as I said previously, A equal to 1, B equal to 0, and C equal to 0. So here you might ask question why it is coming as a negative. So in the program, what it does is that it writes the very minimal. It could be 10 power of minus 16 or 17. So even though we have that, the scientific number it shows the value. So that's why it shows the minus value. But that can be negligible. So we should not worry about it. And also we can use a polyfit and provide the order here, and it gives you the 1 minus rows. And fourth order, as I said previously, we can use the same by changing the function at the call the function side. So any method for this, you will also see the same solution for x square, except the first one. If you do the first one also, we'll be giving the same answer because first one I don't want to do it. It is like kind of more complicated. So till now, it's a single variable problem. Now let's look at multivariate problems. So this problem, they have done it in plant, I mean laboratory, and they measured the concentration of SO2, SO3, and oxygen for the reaction between SO2 and SO3. And they also have reaction extent. And they try to fit this equation using this format. And this is the reported data. I mean, reported equation in the model. So here, sorry. So the equation is like R reaction rate extent equal to concentration of SO2 square root of concentration of O2 minus concentration of SO3 divided by 73 all divided by A plus B C SO3 square. Here we know all SO2, SO3 is concentration of O2 data with respect to R, but we don't know about A and B. Now it's our responsibility to uh, solve A and B coefficients. Now, is it possible to identify the relation between relation of A and B using our first method? It's very impossible because these are not a polynomial equation. This is not a straight single linear equations. It's a non-linear polynomial equation, non-linear non-polynomial equations. So we cannot use our first method. And second method, which is a backslash, that cannot be used because that is valid only for the polynomial equation. Third method, which is the polyfit, that cannot be used because it's again the polynomial equation fitting. But the fourth method, yes, we can use the fourth method and try to fit it. So this we have written already, and the solution of A and B are given as a 0.01 and 0.1023, and B will be 15.9949 by using a least square minimization method for non-linear, non-polynomial equation that was solved using LSQ non-linear equations. So by looking at this, all four methods will be possible for linear regression equations. And for the data science and data approaches, we start with the linear equations. We won't go with non-linear equations. I mean, non-polynomial equations. But for real chemical engineers, I would suggest use physics equation because this is called a physics equation. Typically, if we have a temperature and versus the pressure data, right, vapor pressure data. Typically, data science people, what they do is that they try to start with a linear equation with the single order, multi-order polynomial equations. They may go either exponential or logarithms if they have understanding. But typically, you know, right, how vapor pressure is correlated with respect to temperature. I hope you remember Antoine equation, which is the logarithmic function, log p equal to a minus b plus c, b divided by c plus t, right? So if you know the function of, because that is very important because sometimes if you predict linear equations or polynomial equations, that equation may not be applicable for wide range of the operating conditions. But if you try to fit an equation which is a physics-based equation, then it could always fit for wide range of data. Even though you don't have wide range of data in the data set, but that will be valid for uh, out part of the range. What I mean to say is that you have a data point from temperature of 1000 to 100 to 200, and if you use linear equation and try to predict the temperature be less than 100 or greater than 200, you will always see deviation and the confidence on the solution will be lesser. But if you try to fit physics equation, you will see error definitely, but the confidence will be better because you are using a real physics equation that's happening. That's what I did in the previous section models, which is similar to here. So we try to develop a physics equations using a data. And let's look at other example is PR versus A. So there is a heat transfer problem, and they have a Prandtl number versus the area. So you have typically we already know what kind of relation will be. It's a we try to identify Nusselt number, right? Nusselt number equal to A times of PR power B and Reynolds number power C. Depending on the zone or depending on the type, the A, B sequences will change. So now heat transfer coefficient equal to, we have only one data and try to correlate and try to use our physics equation here. And we can solve them using MATLAB. And the code was given here and the solution was 0.332 and 1/3. And similarly for, and in the first problem, this problem can be solved through least square first second method also. Please 1 minute, sir. I'm sorry. I'm sorry. So in the first, here we can solve this equation through least square minimization method, which is the first and second method. How to convert them, we already know by taking the log in each side, log A equal to log capital A equal to log A plus B times of PR, log PR. So log PR will be my X, log A will be my Y, A, B are the coefficients. We can use, once you take the logarithm, you can, it converted into linear equation, we can able to solve it.
ஆமா இந்த இன்விடேஷன்ல ஜனனி பேர் இருக்கு.
And there is other function for the same. We have a correlation in a different manner, and to solve them, we need to use a level optimization method. So, by looking at this, I think we'll be able to see the. Am I audible? First of all, yeah.
There was some background noise and we just muted, no problem, sir.
Okay, thanks. So I hope these training sections are useful for you to understand how to implement and which methodology that we need to consider for which kind of problems. And I suggest for the chemical engineers, not only chemical engineers, but any data engineers, I prefer to use physics equations for the data. You may have doubt if I have some random data from the Facebooks and all. So those time we cannot able to say. But when you try to solve for chemical industry problems or any process centric problems using a data science approach, try to use as much as possible a physics equations. So because those equations will valid for wide range of the scenarios. Now, since we understood the algorithms, and let's see what all tools typically we have to solve it. Okay. If you see in the slide, it gives you some kind of tools available for all kinds of simulations. Okay. And also provided some tools for the process industries. What are already available, developed model tools, especially for analytical perspective. And there are 23 typical data toolboxes are available for the data science and data analytics. A lot of people are using it. There are more than 23. But I have listed here which is mostly used out of hundreds of the toolboxes that's available. Tools are available. And out of 23, I have mostly come across Python a lot, and R is a lot. A lot of people are using Python is first priority, and R is the second priority for the analytical and science-oriented projects or problems. But also along with that, I could also see some Tableau and Power BI for analytical perspective. And Jupyter is again similar to the Python. And MATLAB is also, which is said now, MATLAB is also a software where we can do all kind of machine algorithms and data science approaches. And for me, if I ask which tool that we need to use it, so MATLAB is a commercial software. You need to spend some money from your pocket and try to buy the software. So if you have sufficient money, you just need to buy a MATLAB for all the kind of things. Then you can start working with MATLAB, because MATLAB is I prefer more in MATLAB because it's user friendly and also does not require declarations, which is more critical. Sometimes it might create issues when you debug the programs in any other programs. But Python is a freeware software. All the libraries are available in the sources, web sources. Just Python can be used. R is also freeware, but Python is mostly people are talking about 60 to 70% of the people are using only Python in any kind of industries. It's not well for chemical industries. But the problem in Python will be the support. So if you're stuck somewhere, then getting support is like help. You need to search in Google and try to follow in the forms, Google Forms or some other forms to get your queries and resolve them. So these are the tools available in the left-hand side table. If you see the list of the tables around 23. But for chemical industries, right, typically in chemical industries, people very lazy to use the handy tools. They want to use directly the available tools for the process industries so that they can directly correlate it. So there are many tools available for the process industry, for the process analytical tools. Because as I said in the previous slides, for the process industries, it does not require any classic clustering. It just needed only supervised learnings. So those can be done using these many tools. And out of all, I just mentioned four tools which are predominantly used in the industries. And for basically for chemical engineers, when we try to solve any data science approaches, there are few things that we need to remember very clearly. One is to analyze or visualize the data what we have and identify fault detections or downtimes or delay times. That's a very key area. Based on that and visualization, we can able to minimize some unplanned shutdowns or planned shutdowns or some identify the fault and correlate that fault with respect to the cause. And if that is happening in the future, we can able to say, okay, this cause has already happened in the past and this is the action that was taken and take the same action here so that we can eliminate the unplanned downtime. So that can be done easily with the visualization part. It does not require to correlate it. Now, second thing will be identifying the critical to quality parameters, because if you look at any plant, it has hundreds of variables, signals of huge number of time series data, and it may not be that all the variables will be very important to measure the qualities, because only few of them, may all of them might be important, but the percentage of importance will be very less. For example, let's say there are three variables: temperature, pressure, and flow rate. And the flow rate may not affect the yield, but temperature and pressure may affect them more. So that means that uh, temperature, pressure are more critical variable to control the system behavior, not the flow rate. So identifying them is a very risky and task driven. And identifying the CTQ variables, there are multiple ways to identify, but one of the popular method is principal component analysis, where we can try to order the principal components and see which variable is more predominant. Or also you can use statistics method, that is a t-test and p-test will give you the importance of variables with respect to the output variable. Once we identify CTQ variable, then we need to look at machine learning algorithms like regressions, correlations, or coefficients. Once we develop that, we need to predict future, that's a forecasting it, then optimize the process conditions. And all of them, basically, whatever you do, but the plant people, they don't bother. They just need a kind of graphical interface where they just see the conditions and they just need to see what they need to modify it. So that's why we need to identify whether we can able to create a dashboard or not. So these are 6 different key elements I typically look at when we try to use any kind of analytical projects for the process industries. Is it clear? Any doubts?
Yes, sir.
Yeah.
It's clear, sir.
Okay, fine. Thank you. So with this, we have covered the background of methodologies available and list some examples of V-square method and also tools available for you guys to take. Uh, and all the process tools are not free tools. All of them are commercial tool and more costly. So I suggest you guys to start with Python, because that is a freeware. Python or R is the one where you can start with it. But if you have MATLAB, I suggest you to look at MATLAB. And Power BI and Tableau, you can able to install open package for 30 days, and you can utilize them for whatever you want to do it. Okay. Now let's take the example, not example, it's a title. What I have title mentioned is that identifying the right production, right conditions to estimate the good quality product and using predictive model. Okay, so let's start with that objective title. And for to demonstrate the title, I just taken one example here that is called FEM mill. So this is like kind of milling the solid particles and grinding into smaller particles from bigger size to smaller particles. So the challenge here is that let me explain. Basically, here is the components present here is that so there is a continuously bigger size particles is going to be ACM mill. This is a typical ACM mill, and the one side will be the solid particles, and bottom will be air, and the top will be product fines which is coming out. And the bigger size particle, there are two sections that divide here. One is the grinding sections, which is in the bottom plate, blue color. One is the classifier sections, which is the green color plate. And both of them are rotating each other. So both of them are rotating in a different speeds. It could be same or it could be different. So when the bigger size particles are coming here, while it is rotating it, what happened is that bigger size particle try to move towards the one side of the rotating frame and try to hit it. When it hit, it breaks down to the smaller size particles. And with the help of air, what it does is that the smaller size particle try to move towards the classifier, and based on the classification, if you write force balance across the particle, the force balance will determine whether particle can move into the classifier and go to the outlet or not, based on the drag force on the particle. So both of them are moving. You can see much more wider picture here. And the bigger size was heated here and breakdown, and it is also heated here and breakdown. And this air was moving like this. And the fine particles are going from the classification and it's going to the top. So bigger size particle is always continuously rotate here and break down for the breakage, and the small size particle will always go to the classification based on its particle balance force balances. And these simulations were developed using Aspen Plus. The flow diagram here, just forgot about it, how it looked like. But the challenge here is that basically, when we try to solve this, one challenge here, what I face here is that we don't know the material properties, we don't know the physics properties. For example, if I want to use breakers phenomena, what is my kinetics of the breakers that I need to supply to calculate the breakers that is happening? So that is a very challenging for me. Now look at the equations here. So this is the typical data that they have, and the equations which are available. I hope this time some chemical engineers might be there and they might remember the mechanical unit operation of, courses where they might have studied three different level of laws for breakage formula. One is Whittinger's law, Bond's law, Kick's law, and so each law will be applicable for different size of the particles. And here I'm using Bond's law because my particles are more than 50 mm particle to the inlet. Once we select the Bond's law, then we need to identify functions for basically breakage or distribution functions for calculating the real phenomenon that's happening. So here there are more models are available, but I'm just using RRSB model, which is a Rosenthal Stirling Bennett model, and that model kinetics are given. I mean, the equations are given here, and the challenge here is that identifying the order n is a challenge, but D63 can be calculated based on the feed distributions, and D is the current diameter. So n is one challenge that we need to have, and the steepness of the distribution can be also calculated from the data that we have. And when we look at the PST calculations, there are two functions called as the breakage and selection functions. So breakage selection functions are completely depending upon the probability of breakage. So I have used these functions to calculate. And here the metal properties as well as the resistance of the breakers are the unknown functions uh, that needs to be estimated to correlate the right functions here. And there is a breakers function. Previously it's a selection function, now it's a breakers function, where the breakers function has been, I have used, this may not be important for you, but I have used this function where I have phi and gamma and beta are my coefficients. And other variables are directly correlated with respect to the free diameter. Now, looking at these equations, right, for the there is a classification based on the flow chances. So, on the side, I have, as I said in the previously, I have function coefficients, physics function coefficients, which I need to determine. Now, to determine them, what we have to do is that there are multiple ways. You just collect a series of experimental data, try to correlate them for this, and try to identify all the 7 variables using the planned data versus the model data. But here, since I don't have much planned data, what I have done is that I try to change the all input variable between the range min and max. I have ran more than lakhs of simulations among all 7 by using factorial design. And once I develop this database, it's a simulated database that I try to correlate the PS variables, which I have given in the bottom table, the coefficients of the equations. So these are not linear equations; these are non-linear equation. For one PSD particle is like linear, but other are non-linear equations because it's a logger functions. And this fitted equation have very good R square. You can see the R square are really good. Now you have the output versus the input functions. Where inputs are here my function variables and physics variables coefficients, and I have only single point. And once we develop this, I try to validate them using the different set of variables for different set case. You can see most of the cases my PSDs are very valid except the few data points. So now we have these functions with respect to all the variable. Now it's our responsibility to calculate what is my x1, x2, x3 for given conditions of the my process. So how I have done is that I know my input and output PSD, a single data point. So that is from the dotted points from the plant, and I know the equations for parameters as model parameters, and try to use optimization algorithms to predict what could be my model parameters such a way that I could be able to get the same match as per the plan data. So that was predicted using a developed machine learning algorithm model and used optimization to calculate it. So once we have model parameters for existing process, then we started working on parametric analysis. So these are called process parameters. Previously, it's the model parameters, and these are the process parameters. Model parameters were estimated based on the simulated database and machine learning algorithms. Now, with that, we predicted optimal model parameters for current process, right? So, with the current process, we need to study different process variables and identify better process conditions to get good quality of the product. So there are 3 major parameters. If you remember previously, there is a grinding speed and the classifier speed and the airflow rate. So all of them are affecting the particle size that is coming out of the ACMLs. Here, if you see, when we increase the grinding speed, that means that you're rotating much faster. When you rotate much faster, you'll be able to see more collisions are happening. When we have more collisions, you will have very fines that's coming out, so that you are able to see at a higher speed you will have a very fines, at lower speed you will have a very coarse is coming out. Similar for the classifications, when we have more speed of the classifier, then the drag force will be very small because particle may not move towards that space between the two classifier blades. So that means that we'll be able to see very, very fines, and most of the particles will be in the grinding zone itself. So that's why you could be able to see at higher speed, you will have very fines. But coming to the high air flow rate, when we have higher flow rate, that means that air is going to decrease the drag, because the force of air is, the drag force is always in the downward directions and the air force is always in the upward direction. When we have higher airflow, the drag will be lower and lower, so the particle will stay at the grinding chamber itself. So that we were able to see at higher flow rate, we will able to see very low particle size that is coming out. So since we know these three, and also have presented current conditions, and we studied the individual sensitivity analysis based on the machine learning algorithm developed for the process model parameters. Once we know, then what we did is that we try to identify the process conditions when we want to improve my productivity from 1100 to 1200, 1200 to 1400, 1500 of the throughput solid flow rate. Because the basic problem what we see here is that when we try to improve or increase the productivity of the mill, I'm not able to get a very good particles. So now here that I want to meet the same particle distribution that is coming out of the coming out of the ACML, to get that at a higher rate, what should be my operating regimes of the operational conditions? That was estimated using previous models. So with this, there are two levels of machine learning algorithms were conducted here. One machine learning algorithm is to identify right model parameters for given given plant data. Second machine learning algorithm will be identify right process conditions to control the particle size distribution at higher run rate. So this is how I have applied machine learning algorithm. Basically, I apply linear equations, but least square minimization method, but not the linear equations. All of them are non-linear equations. So we have used a non-linear optimization method to solve the coefficients of the machine learning algorithm coefficients. So with this, I'm concluding for the today's discussion. So I'm open for the questions. If anything is there, please let me know.
Thank you, sir. Now the session is open for discussion. So participants, if you're having doubt, you can post in a chat box or you can raise your hand so that we will unmute. So you can ask your questions directly to sir. You can clarify your doubts. Now the session is open. Post your questions in chat box now. Any doubts from the participant side? Any questions? I think, sir, if you have your mail ID, you can post in the chat box. So if they have any queries in person, they may contact you. So it would be nice if you shared your mail ID. So if you're interested in the chat box. Thank you, sir. So
Yeah, I have already posted, and one question was came. So can we model the particle size distribution in the case of cyclone separator? Yes, you can model particle size distribution in cyclone separator as well, but in the cyclone separator, you just separate the particles based on the density and based on the velocity. There is no breakage phenomena that's happening. It's much simpler compared to the milling sections. But yes, you can solve a particle size distribution in the case of cyclone separators. Yes. Typically, the cyclone separator, it's not 100% efficient cyclone separators.
any other
You
questions?
can use Aspen. If you have Aspen as experience, then you can solve Aspen to solve any kind of cyclones or milling sections. But sometimes in Aspen, basically in Aspen, I think you might know that all of them are auxiliary equation solvers. And, and Aspen is not right one to solve solid physics. So it's our responsibility to estimate the model parameter and use the Aspen for our needs. So it's our responsibility. We cannot use directly the coefficients what they have to get to match actual data. Basically. Well, for the student purpose, I don't think it's different, but you can use always get experienced. But if you want to validate the model with our literature data or lab data, you need to tune the model using external or within Aspen itself, we can tune the model and model parameters and use that as a model variables for the calculations. And I have also posted my email ID in the chat window. Please reach out to me whenever you have a doubt in any chemical engineering related or machine learning algorithm related. I'll try to answer or address on at least much quicker.
Thank you, sir. Thank you for the enlightened speech. So you have shared your technical skills and programming knowledge you have shared with us through MATLAB, and it's really more informative. And also, sir, you have also explained, gave the brief outlook like tool analytics that are important in the area of process industries. So it's a great honor to have you in Atal FDP program, sir. On behalf of our organization committee, members of MBJ College of Engineering, Department of Chemical Engineering, and also from the management side. So I really thank you for sparing your valuable time with us today, sir.
Thank you so much, and it's my privilege to be a part of a speaker during this conferences. And thank you so much.
Yes, sir. It's really a very informative session. So whoever is willing to ask some queries, they can post directly to the sir. Sir has posted the mail ID in chat box, so you can reach to sir directly. And thank you so much, sir.
Okay, some questions are came here
Yes.
related to. Thank you, sir. Very informative to know data sets, models, decision engineering.
And share the link where you can get the software.
So which software you're referring to? So that depends on the link, right? So which software that you refer? Aspen is not a free software, first of all. So there is no open source software, but there are open source related to process simulator. I can try to search and send it to you. I think you mentioned it, Sasikala, right? Sasikala, if you can write a mail, I'll try to give you some links for the open source process simulator. But for the data analytics, Python, I can share the link where you can download the Python software.
A few more questions were there.
For the Tableau, yes, I can share you the link. If you just try to search and Google, you will get it. Any more questions, ma'am, that you're able to see here? No, I don't think any sections, any questions are available.
Yes, sir. Thank you, sir. Thank you,
Thank you
sir.
so much for giving this opportunity. And once again, I thank Sayana for giving this opportunity.
Okay, sir. Thank you, sir.
Yeah.
Thank you so much. The feedback link is already provided in the chat box. So participants kindly fill the feedback form, though it is mandatory for calculating your attendance. So 80% is mandatory to appear for the exam today after the validatory function. So kindly fill the feedback form. And next session will be starting by 11:30. So after a break, please come back for the next session. That's a final session of this day. Thank you, sir.
Thank you so much for giving it. Bye bye for now.
Thank you, sir. So, thanks.
ಇಲ್ಲ ಇಲ್ಲ ಇನ್ನ ಒಂದು 10 ಗಂಟೆ ಆಗ್ತದೆ. ಸರಿ ಸರಿ ಮತ್ತೆ ಕೆಳಗೆ ಮಾಡ್ಬೇಕಾ ಮೇಲೆ ಮಾಡ್ಬೇಕಾ? ಹಾ 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 ಸರಿ ಮತ್ತೆ ಆಯ್ತು. ಹಾ ಹೇಳಿ ಇನ್ನ ಅರ್ಧ ಗಂಟೆ ಆಗ್ತದೆ ಬರಕ್ ನಾನು. ಹಾ ಹಾ
Exactly what I told you is that I can give you more business where you should be those small companies. See, there are loans to areas, just like US and Europe, you get a business right. They do a citizenship also. So I'm thinking it would be steps ahead. How to answer that. Okay, so if I can set up some company there and he provides the resources, we can be in a partnership basis. We can replace visas and I will take care of it. And anything is to go and talk to the people and get their business. We should agree to this mark. 2005. You never realize it. So you told it call and talk about this. You want to talk more?
Yeah, that's why he will explain what the customer comes from. He will call them.
Okay. ಇಲ್ಲ ಹೌದು ನಾನು ಹೇಳ್ದಲ್ಲ ಓಕೆ ಓಕೆ
ಇವತ್ತು ಮಾತಾಡ್ತಾ
ಸರ್ವಿಸ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್
ನನಗೆ ಸ್ವಲ್ಪ ಹೈಯರ್ ಇಟ್ಬಿಟ್ಟಿದೆ ಕಾಫಿ.
ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ ಮಿಲ್ವಾಕಿ ಮಾಡ್ತಿದ್ದಲ್ಲ ಅಂದ್ರೆ ನಾಟ್ ಮಿಲ್ವಾಕಿ ಇಲ್ಲೇ ಮಿಲ್ವಾಕಿ ನಮ್ದು ಪ್ರಾಜೆಕ್ಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಾಫ್ಟ್ವೇರ್ ಡೆವಲಪ್ಮೆಂಟ್ ಚೇಂಜ್ ಯಾ ಇಲ್ಲಿ ಇಲ್ಲಿ ಇನ್ಫ್ರಾ ಚೇಂಜ್ ಇದೆ ಮಾಡೋದು ಅಂದ್ರೆ ಓಕೆ ಓಕೆ ಅದೇ ಅದೇ ಇಂಜಿನಿಯರ್ ಹೇಳ್ತಾ ಹಾಂ ಹಾಂ ಓಕೆ 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 ಈ ಸ್ಯಾಲ್ರಿ ಎಷ್ಟು ಹೇಳ ಬೇಕಪ್ಪ ಬೇರೆ ಮತ್ತೆ ಬೇರೆ ಏನು ಕೇಳ್ದ ಓಕೆ
Coffee only, sir.
ಓಕೆ 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 ಬಟ್ ವಾಟ್ ಅಬೌಟ್ ದಿ ಆಟಿಟ್ಯೂಡ್ ವಾಟ್ ಇಸ್ ಓಕೆ ಓಕೆ he will be able to take up things which he doesn't know and go and complete it. Okay, okay. Right. No, technical, but technical, what I'm saying is technical, of course, but will he be able to learn and something and wherever he cannot then take help. One second, huh?
Ukkabati. Correct.
I love you. Okay, okay. Configurator, okay, okay. ಓಕೆ ಹಾಗಾದರೆ ಡೌಟ್ಫುಲ್ ಅಲ್ಲ ಇಲ್ಲ ಇಲ್ಲ ಇಟ್ಸ್ ಟೂ ಲೆಸ್ ಇದು ಅಂದರೆ ವಾಟ್ ಯು ಸೇ
Good morning, sir. Hello.
Hello, am I audible?
No, sir, your voice is very less.
Better now?
Um, it. Hello. Sir, you just check whether your presentation is there. I'm making you presenter. You just check your PPT.
Okay. Hello.
Hello.
Yeah, is it better now?
Yes, sir, sir. It is better
Yes.
now.
Okay. So let me just share. Please confirm if you're able to see.
Yes, sir. Please share.
Yeah, are you able to see this?
Yes, sir. Yes, sir. It is visible. So we can start after 5 minutes because participants are joining now.
Yeah, sure.
Okay, sir. You just put the slides here only.
Okay.
Okay, sir. Thank you. Sir, shall we start?
Yeah, sure.
Okay.
Okay. Good morning, everyone.
Sir, I will
So
just
let me just
introduce you.
directly jump into the quick of today.
Hello?
I have,
Hello, sir. Sir, just a minute. I will introduce you, then you can start.
yeah, sure.
Okay. Learn continually. There is always one more thing to learn. With this inspired thought, I would like to start the session. I am Sakshi, Assistant Professor of Department of Chemical Engineering. Good morning, everyone. Heartily welcome to all the participants who have joined for today's session 14 on the last day of 1 week online FDP program sponsored by AICT Training and Learning on Data Science and Artificial Intelligence, Chemical Engineering, Recent Trends and Future Outlook, organized by MBJ College of Engineering, Department of Chemical Engineering in association with IAC and IQAC. Now we have our most honored person, Mr. Sri Sandeep Adik. Sir, APC Engineer, Yokogawa IA Technologies India Limited, Bangalore. Let me brief some key credential of his achievements. Sir has graduated from NIT K Surathkal in Chemical Engineering. Sir has experience of working in various key departments of large-scale refinery from operation to supply chain management. Sir was previously worked at Reliance Industry Limited in operations and supply and trading margin optimization. Currently, Sir is working as an EPC engineer in Yokogawa IA Technologies. Sir has involved in many projects that leverage data science to develop advanced solutions to the refineries and other chemical industries. So, with this short note, I would like to invite Mr. Sri Sandeep Sir to deliver his speech on how artificial intelligence and machine learning techniques can transform dynamic modeling for advanced control and optimization in chemical process industries. We welcome you too, sir, in FTP platform.
thank you for the kind introduction. So if it's okay, I'll start now.
Yeah, yes, sir, you can start now.
Okay. I have two separate topics for today. One of them will cover what actually happens in ML, the workflow of ML in industries. The second one is kind of a demo, how we can do the dynamic modeling of a naphtha split. Okay. Before we start, we'll discuss 3 points on machine learning. Why is machine learning so important, or why is it that it is being catching up nowadays? One of the things that machine learning offers is flexibility. The flexibility of models, also the compatibility. Then you also have utility. Utility in the sense, usual traditional models may not offer you a variety of utility compared to ML. So in the sense, ML can be employed at different levels of at different levels of industries. For example, you can use machine learning in supply chain. You can use machine learning in RTO. You can use machine learning in APC levels. Okay, even in a given level, when you're doing a project, it can help you at different stages of the project. For example, you want to do some sort of outlier detection, or you want to do some feature selection. So all these things, machine learning can help you with. Okay, it is not only the modeling part that machine learning helps you in. So that is the diversity that machine learning offers. So what is the difference between ML modeling and traditional modeling for in context of advanced process control? So your advanced process control, it usually has these transfer function models. ML can offer you some sort of modeling for complex processes as well in that comparison. Okay. Let us say even after you have the traditional models, ML can still offer you sort of incremental benefits. See, if you can just imagine, if there is 10 cents of improvement per barrel in an industry, which processes 1,000,000 barrels per day. So, it becomes around $300,000 per annum. So even a very small change that ML can offer as an increment to already existing models, it can be a huge impact because the volumes in which refineries and other chemical process industries operate, it is huge. Okay. Now we'll just see what are the major drawbacks in process industries for ML. Why is industry wants to research in ML? At the same time, industries are a bit reluctant to employ ML or machine learning or artificial intelligence everywhere. So the two main things that you need to know are transparency and reliability. Your traditional models, they are time tested. They have been here since decades. Okay. ML, although mathematically and in terms of academics, it has been for decades, it is now slowly flourishing in industry. So the issue is the reliability. It needs to be reliable because it is a concern of safety, not just profit, correct, in chemical industries. The second thing is transparency. All these transfer function models, they are quite transparent because we know how it works inside out. So ML models, not all of them are really opaque in the sense. Some of them are transparent, but some of them, such as like neural networks, etc., they are not really transparent to the user. It acts as a black box model. So if you input some data, you will get the predictions, but you will really not know how that predictions are coming. Right? So those two, reliability and transparency, are two things that that are not really up to the mark in terms of process industries. Of course, there are methods in which you can cover these two, like transparency can be covered by some sort of simulations on your model. Reliability, over the time, it is increasing. Okay. Now we will just move to the, of course, if you have any questions, feel free to stop me and ask me, or you can also reserve it to the end if you think it can be reserved. What are the stages in ML? So first thing is you need to have, so the stages of ML is for explaining the workflow. How we do machine learning, or how we do machine learning process or projects in industries. What are all the things that are required? So first thing is you need to understand the different types of data even in the context of advanced process control. So we have different kinds of data and we have a procedure for collection. So the first and foremost step is data types and collection. So data can be numerical. So we all know numerical data, which comprises of numbers. So in numerical, it can be continuous. Continuous in the sense you have it equal intervals of time. Let us say you are collecting minute data. So you have data at every minute. So it can be discrete. So discrete and continuous are in a different sense than what you usually find otherwise. So here discrete means it is an intermediate data. For example, you have process data in which you can collect temperature, pressure, etc. every minute. But discrete data can be your lab data. So that lab, the lab analysis happens, let us say once in a day or twice in a day. That can be a discrete point for modeling. Okay, so this is continuous and discrete. Then there is categorical data. So categorical data, these are not numbers per se, but they are differentiated into different categories. You see a graph here, right? A plot. So in this plot, it is showing the total bill of a restaurant. This is over a week or something, and this can only be modeled accounting the day of the week. Otherwise, this model might not give you a proper result. Okay, so when you look at this, on the weekends, it has a different story to tell, the data points. On weekdays, it has a different graph. That's why categorical data, they are important. How categorical data, what sort of categorical data can we find in APC? You can see here, you can see that modes. So mode of a controller can be auto, manual, or cascade, right? So this is important. The model that you work on, the data that you work on for a model should have these coordinates as well. Otherwise, you will not be able to model it properly. Let us say you have a control loop which is always in auto, but the data that you collected is when it was in manual. So the model that you are going to prepare is going to give a good prediction only when it has a manual mode. So that is why you need to take into consideration of the mode of the loop, then collect the data accordingly. Like whichever is the mode that is going to be prevailed. So that mode is the one that you're going to use for modeling. Okay, that is categorical data. Now there is something that is ordinal data. Ordinal data is, there is an order, but you will not be able to say what is the actual value of delta between the two categories. For example, here you see what the education background can be elementary, high school, undergraduate. I mean, in our sense, it can be graduate and postgraduate. Here, the example says undergraduate and graduate. You can see that preferably you want 4, and it keeps on increasing. The desirability is from 1 to 4. Like 4 is most desirable, but you cannot really say what is the value. I mean, the delta between elementary and high school or undergraduate or graduate. What is the delta in terms of qualification? Correct. Similarly, in advanced process control context, we can have something called as our advanced process controller. It can be in inactive mode, wherein it does nothing. Standby mode, wherein it takes all the inputs, but it does not give any feedback or does not do control. Active mode is when it actively controls the process. Optimized is when it is controlling and it has optimized the process. Now it has reached a steady state where it is most beneficial. Okay. Here you again see that desirability is always 3. Least desirable is 0. So whenever you're modeling, maybe you have to pick cases of 2 and 3 instead of 0 and 1. So because these two are most desirable, it is expected that your process is going to be in this form. Like it can be active or it can be optimized. And this is ordinal data. So these are the data types. So let's just move to the types of collection. Okay, what all we can, how we can collect data, and what is the importance of data collection. So like I mentioned earlier, there can be, this data collection is the process of gathering data, of course. You need to collect both ones that you want to model and the inputs for those model outputs. So it can be process data where it is continuous, it can be lab data, so it can be discrete, it can be log information. So this is quite important when you collect data. Maybe there is an event or emergency that has happened, and it is not always going to happen. It is once in a while, like once in a 15 days or once in a month, that event may occur. So if you collect the data when there is such a sort of anomaly, you might not get a good model. So it is important to collect log information also. Another thing is log information is used for also can be used to categorize your data at a later point of time. For different cases, you can say, okay, this event A has occurred 10 times. So you take all the data that belongs to event A and you model it separately. Okay. So you have to fix the scope of the model. What is the overall scope you're trying to model? Are you trying to model for a single process and single variable output that you're trying to calculate? Are you, let us say you want to just calculate the quality, nothing else, or you want to calculate the whole process? Let us say you have 5, 6 different outputs, you want to calculate all of them. Or and do you know the inputs? Do you not know what are the inputs? You have to choose input from a cluster. So all those things you have to fix. So this helps you in data collection. So you will know what are all the data points that I have to collect. So you sometimes these data collection happen in step test format. You cannot keep on requesting for step test data with the process unit. Okay, that is why you have to fix the scope of the model before you even start the data collection. Then you have to fix what is the nature of data that you require. It can be time interval, it can be duration, it can be scenario. So let us say you have a very fast process, that very reactive process that happens in terms of seconds. So if you collect an hourly average data for those kinds of process, your model is going to be useless, correct? So not only that, duration in the sense, it can be 1 week, or it can be 1 month, or it can be year long. So you want to capture as many as inputs in that data. So seasonally, your plant might change the way it behaves, right? So you have to capture that. So you want to have at least 2-3 years of data if you want to capture the seasonal changes that happen in a plant. That is why duration and scenario, it is important. If you only collect data for in summer for 4 years, 4 years or 5 years, you have only some 6 months of data, and that covers only summer season. It does not cover winter. So what would happen is your model would probably perform better in summer and might not be up to mark, or it might perform very poorly in winter, because it does not consider a lot of ambient factors that might affect the process during that season. One last thing that is very important is the data sanity check. Once you collect data, there is a chance that it might get corrupted, or you might get some blank values, some erratic values, or zeros. So it is always a good practice, if you're collecting it over a period, let us say 7 days. So you do this check every day. You minimize your damage if there is any. Okay, then you export and see that your data is okay. This is the data collection part. Now, one of the most important aspects of ML in industries is the data preparation. You have to structure your data, you have to profile your data. So what do you mean by structuring and profiling? Profiling is when you are actually categorizing the data. Either you are saying that these points are going to be lab data, these are going to be the continuous data points, these are going to be discrete data points, these are going to be event logs. So that is, you profile the data, you structure the data in terms of how your original modeling technique requires it as an input. Okay. Then there is data visualization. This is an important step for SME in the sense subject matter expert. Lot of techniques of machine learning are common across several different aspects and cross functionals, not just in chemical industry, but also other industries, which you might be aware of. So the one thing that separates a chemical engineer who is able to do the machine learning process, or who is able to do the machine learning model, is his knowledge on the domain. Okay. So that is how that is why visualization is very much important. Just by looking at the graph, you will be able to make out that this process or this values are correct or not. Okay. So just following up with data visualization comes your data vetting and cleaning. For example, chemical engineer, it is easy to know that for a chemical engineer, if a flow is shown as negative, so you can say there might be an instrument error. Or let us say, instead of 60 meter cube per hour flow, the flow just reduced to 30 meter cube per hour for 15 minutes. Then the flow came back to 60 meter cube per hour. But there are no changes whatsoever in the rest of the process. So you know that there is an instrument error which has caused this. So this is something that can only come with the experience of the domain. Okay, that is why data vetting and cleaning is usually done by domain experts. Here you can have outlier detection, bad data segment elimination, and noise cancellation. These three are different. Outlier can be the bad data segment elimination can be when there is an instrument error or some issue with the instrument. So complete segment is not giving you correct values. So you eliminate that segment. Outlier can be correct values, from the measurements, but still you may have to eliminate some of them because they might not truly represent your process. Okay, you might be in a operational regime that you want to have the model, might not be the one. So then you them out as outliers. What do I mean by this? So let us say a normal process is going on, and due to some sort of emergency, there is a scenario going on for half an hour or 1 hour. So the values that you are going to get are actual correct measurements, but still they are outliers because they do not really represent the process that you want. The process that is supposed to be modeled, they do not represent that. That is a very specific scenario. So you do not really consider those points. That is how you delete outliers. It can be data-wise also it can be outliers. So noise cancellation is mostly because of instruments. You may see a lot of noise in your data. So that has to be eliminated by, you can use some sort of filters, etc. This noise cancellation will help you in modeling better. So we'll come to feature selection. Feature selection is also input selection. Okay, you have inputs, you have outputs. Not always you are given like these are my inputs and this is my output. So what is the relation? Usually it is like these are the outputs that I want to predict. And when you ask for inputs, you get around 500 tags. Okay, a small scale plant would have around anywhere around 150 to 200 tags of or variables or input variables. It can be temperature, it can be pressure, it can be flow. A medium scale unit might have around 500 to 600 input variables. So you can reduce this by feature selection technique. You reduce a whole bunch of input variables into the ones that are actually impacting the process. There are several methods, but most reliably this can be done by a domain expert. Okay, he can actually tell that these are the ones that are actually affecting the process, these are not. Anyway, even that process can be aided by ML. How you reduce a big set of variables to a smaller set, and in that smaller set, a domain expert can further refine. Okay, there are several methods to do this as well: feature selection, or you can say input selection. So now coming to modeling, see this is a very well-known image actually. You see there are three types of models here. The data points are same. First one, there is high bias, meaning to say underfit. We are having a linear model for a process that is very apparently non-linear. In third case, to have a non-linear model, but you have gone way too far to capture all the points. Okay. There is one more model which is just right. This is nonlinear model, maybe quadratic in nature, and your model is also quadratic in nature. So that's why it's able to capture it. What would happen, although the last case, high variance overfit, it is capturing all points, what would you expect if there is another point where you have to do a prediction? Okay. So it is quite clear that even though the model is capturing all points here, would not really represent the underlying process. Okay, so that is why it is very important to get the model right. So even in modeling, you have to first do a selection technique. It can be a single model or ensemble of models. Single model in the sense you can either have let us say linear regression, or it can be PLS, etc., or it can be bank of models. So what is meant by bank of models? Bank of models is when you are going to ensure that you have more than one model and they give you some sort of an output, and based on the training you know which output to pick. So that can also be done in the modeling section. Now there is something, this is very much particular to ML, that is training your model, then there is validation, then there is testing. What is training model? When you have data, if you have a minute data for 1 month, so that will be around 45,000 data points. So you have to divide it into 3 parts, not necessarily equal, 3 parts, which first part you're going to use for training the model. While training the model, your validation can be used to say when the training has stopped. Okay. So what you usually do is you train a model, you predict on the validation data set. So in whole the total amount of data available, you split it into, let us say, 70 for training, then 15 for validation, 15 for testing. So that is going to be 100. So 70% you start training, and once you train the model, you predict the values for the validation part. Okay. Then if the validation is correct, then you move ahead. Okay. This training and validation and testing, although these are 3 different parts, in some cases validation and testing can be clubbed together. It will be only 70 and 30 split. You train on 70% and you test on the remaining of it. Once you've done this, you have to do something called as model evaluation. So what is model evaluation? Model evaluation is when you are going to evaluate model based on, let us say, metrics. You might be aware of R square, which is this coefficient of determination, or it might be based on visual inspection. You see how your predictions are going when there is a measurement graph. Against measurement graph, you see a prediction graph and say if they are okay or not. So this part we can actually see in demo, how to do this evaluation. Coming to prediction in real time. So this is the last step. You have done you have collected the data, then you have done this pre-processing of data, then modeling. After modeling, you have done evaluation. Now it is ready to be put online. Now your model is running online in an industry. So this requires deployment to runtime. This is not an easy task actually, because there's going to be a lot of disturbance, a lot of problems in even server connections and all those things. So once this happens, now it is time for you to evaluate model in runtime. Maybe your model worked well in training, then also in validation and testing. But then when you go to runtime, there might be different challenges in the runtime. Like I said, if you do not really consider what kind of data you have taken into consideration for modeling, so whatever we discussed in this part, right? If you cannot outliers properly, so these things and this nature of data, these things affect runtime. You can actually see the result. So if there is any issue in the runtime, you have to do that evaluation, go back to your model, do all the exercises again, maybe with additional data, then again deploy in runtime. This is the workflow. Okay. You have any questions up until this point?
Participants, if you have any question, you can ask in chat box or you can raise your hand. And I think no question. You can continue.
Yeah, I'll continue then. So now we'll see a process and how to model with linear regression, multivariate linear regression for a dynamic model. So this is a naphtha splitter. So you see that there is feed coming in, sort of binary distillation. This is light naphtha, this is heavy naphtha. Okay, and you have heating system here. Okay. Hot oil goes in and it returns. There is a reflux. So this is a simple process. But we will only do modeling for this quality variable, bottom quality variable. Okay, so considering bottom quality variable, I have prepared a simpler FD. We'll go to that one. Okay. So what are all the variables that affect this bottom quality? The feed intake would surely affect. Then the top temperature. The top temperature here is cascaded to flow, reflux flow. So whenever the temperature rises, you increase the reflux so that the temperature is decreased. Then the top pressure, there is a fin fan cooler here. It is connected to that. And this is the heating. Okay. Now, like I mentioned earlier, it is important that to collect the data when this is in auto mode. Temperature is auto and the flow, reflux flow is cascaded to that controller. So if the reflux is in manual, even though you have considered top temperature as one of your inputs, it might not truly represent the process. Okay, you might end up with wrong model. Okay. These we will consider for this particular Y002 is the bottom quality. Okay, bottom quality in terms of T95. Okay, T95 is that distillation temperature. So that is what separates, that is one of the main qualities. So we will consider that. This is our output variable. Input variables can be, one of them is heating, hot oil flow, or the feed flow, and the pressure, which also controls the fin fan, the top temperature, which controls the reflux. We will not consider the reflux flow as such because we know that this flow is cascaded to temperature. So variation in temperature would cause variation in reflux anyway. Only these four we can consider. We will be using linear regression to model this. So coming to some refreshing maths, multivariate linear regression. So it can be in terms of represented by this equation. Okay, this is the general representation. Y is the dependent variable, which can be our output variable. Beta naught is the intercept. B1, B2, and BP. These are the coefficients corresponding to x1, x2, so on till xp. These x's can be input variables here. I have 4 input variables. So it can be x1, x2, x3, x4. So I'm sure you would have understanding of linear regression. But just for the context of the model, I would like to say, so dependent variable and independent variable, this is the plot. Okay, these are the data points, and this is the regression line. So this is one-to-one regression. This is not multivariate. It's more of form y is equal to beta naught plus beta 1 x1. Correct. So this has only one input variable. It has an intercept. It also has a slope. So beta naught will be intercept. Beta 1 is slope, the coefficient. This is the usual form. Here, if you look at this, we have several equations. Like I mentioned, if you have 1 month data of 1 minute, you will have 40,000 equations. But of course, the variables, input variables might be anywhere between 5 to 10 or 15 for a given output variable. So this is when there is something called as method of least squares. Okay, when you have more data points than the known variables, what you do is you fit a curve, in this case a line, in such a way that it has minimum of errors, square of errors from each point. So these are my data points. This is the fit line, the one in red you're seeing, that is the fit line. With respect to every data point, you can see that this is the error. What you do is you minimize this error in terms of curve fit. So measured minus predicted whole square, that is the error square, This is the one that you are actually minimizing. The overall square of error is what is minimized. Now, how do we do that? How do we minimize that? That is by this formulation. This was our original equation. It can be directly translated to matrix form as this. Okay, beta naught, because this does not have any variable, this will have 1 across the column. Other variables will have x1, x2. These x1, these are the points that are corresponding to x1, this column. Second column are the points corresponding to x1. And the last column are the points corresponding to xp. You see here, right? x1p, x2p, xnp. So every row here represents a different sample. Every column represents a different variable, input variable. This is our matrix for linear regression. See, this matrix can be written in this form: x times beta equal to y. Now, in traditional sense or in conventional sense, because x is not a square matrix, you will not have an inverse. There are methods to do that, but for the sake of this method, we'll say we'll use a method in which you can also get a least square. You can multiply both sides by the transpose. Then you take inverse of x transpose x. You will get the coefficient beta is equal to x transpose x inverse of x transpose y. The thing is, you can actually show that this is a least square solution. If you take all the equations, if you differentiate, if you consider the error of equation, then you differentiate in terms of minimizing beta naught, beta p, all the variables. Then you derive this, you can actually show that this is the solution. Minimum error will be this case. This is the method of linear least squares that we are going to use in the linear regression. Okay, so it was all story. Now it's time for some action. Okay, we will now see how this can be done. Let me just try to. I'll explain what is being done in terms of code here. It is very simple and intuitive. Here I'm using Python to do this modeling. Okay. We'll first see data. UI002, this was our out. We were interested. Then FC002, 006, T001, TC001. These are all our inputs. So this is simulated data. So you don't see the noise in the data. Okay, and also the movement of inputs are at different time frames. You see all these nice little steps right here. This might not be the case in process industry when you collect data. You might have some sort of disturbance. There might be some noise. Also, more than one this input variable might move at a given point. For better understanding, I have this example. So now you can see that your output variable, it is varying at different time frames, and the input variables are varying accordingly. If you consider this point, there is variation in output, and you can say this variation might be because of this input. So this is 11FC006. There is some change in this input, but seemingly there is no change in output. If you zoom in carefully, you can see there is very small negligible change, right? Also, there is some good change here in this part, but there seems to be no change in inputs for this part. So if you zoom into this section, you can see that the pressure is changing. This is something important that you need to know about scaling. The pressure varies in order of 0.1 in a column. Temperature might vary in order of tens. Similarly, quality, it might be varying, let us say 2-3 degrees or 5 to 6 degrees. The pressure is varying in a very small span. That is the importance of scaling. Of course, in linear regression, you don't have to separately consider scaling because coefficients would take care of that. But if you are using any other methods, it is important that you consider this scaling. Even if you look at this one, there is some variation in FC002. But if you zoom into this section only, then you will see that, okay, there is variation in this section as well, responding to the changes in the input. So basically, this part is the data visualization that you do. You consider the complete data set, see if there are any, of course, there are no outliers here. If there are any outliers, if there are any bad data segments, you have to eliminate before going into modeling. Okay. Now let us see the linear regression. Let me just explain what I have done. Here I am just importing libraries. So this library is just for plotting. This is where I'm importing a linear regression library. Okay. This part is where code reading is happening. In linear regression, this part is for plotting. This is where I'm fitting X, Y. You can say this is the train part. We spoke about train and validation, right? I'm saying that fit X and Y. X is the matrix, this matrix. This is the X matrix. This is the Y matrix. So I'm giving these inputs X and Y, and I'm asking to fit. So this will be the training part. So because I'm not separating the data for training and testing or prediction, I'm using the same data to predict again. Okay, the complete data to predict again and see how the results are going to be. Now we will see what would happen if you do not choose proper inputs. You know, there are we already saw that there are 4 inputs for SQI002. Okay, but here in inputs I will only consider 2 variables. That is FC002, the throughput, FC006, the heating oil flow, and our output is still the quality. You see, we have considered 2 inputs instead of 4. If you zoom into this section, you can see that there are some changes that are happening that corresponds to FC002. There are changes that corresponds to FC006. Although they are directionally correct, if you zoom here, you will see that they're not really capturing the process, right? They seem to be in steps. The output seems to be gradually changing. There's one more observation here. That is, there is no variation for this region. So if you see that the predicted value is showing a straight line, where the measured value is actually varying in this region. Why? Because we have not considered of the other important inputs. You see here, this corresponds to pressure, correct? There is variation here in this region. So this corresponds to the pressure, but we have not considered pressure. So the variation in that region is not captured. And there are some changes of temperature here. We have also dropped that variable. So in this region, there is no variation. If you consider all the inputs correctly, when we consider all the inputs correctly, we can see variations at all points. Let me just zoom in here. See, this is some sort of directionally, at least it is correct. It's capturing all the variations, but not with real process impact, like how the process is actually varying. That dynamics is not getting captured here, only the direction. So if you really consider why would this happen, see, it is important in ML to know if your method is working, why it is working, or if it is not working, why it does not work. Otherwise, it would have been just throw of dice, right? Like you could have had some 50, 60 different models. You just train across all models. You just test across all models. Whichever is the best model, you finalize that for the plant. But that does not work that way, because models are all generic. Okay, and your process is specific. So your model will not be directly applicable to the process. Now we are seeing linear regression is somewhat able to predict process, but it is missing something very valuable somewhere, because it is not capturing the dynamics. When you go back to the input and output, you can actually make that discovery here as well. When you look at the changes in inputs, these changes are all steps, correct? But when you look at the changes in output, they are happening gradually because of the process dynamics, right? When you increase the temperature to a, let us say, a reactor or something, so the inlet temperature, if you increase, it doesn't mean that the reactor temperature will also increase suddenly. It will take time because of the, let us say, residence, or there are several factors, but residence might be the most important one. Similarly, when there is change here, when there is change, when it is varying in the input, linear regression would give a expected output in this way, but it will not capture dynamics. How do we capture this dynamics then? Because linear regression is able to predict the direction, but not the dynamics. What we can do is we understand that variation in output variable is not just dependent on the value of input variable at that particular point of time. There is some sort of lag in the process. So we have to capture that lag, capture the dynamics of the process. How we capture this lag? This is called capturing. For capturing lag, we will enhance the linear multivariate linear regression with this lag or shift variables, right? So you have input, then you make one lag. So this is first lag. First lag is shifting the input from time t is equal to 0 to time t is equal to 1. Okay, it is important that you understand this process to appreciate what would happen after this, right? Because see, you did not have inputs, proper inputs, you had only 2 instead of 4. Your score, the fit score was very less, 3%. Okay, 24, 23.9, 24. You have all the inputs. There's nothing else that you can add. Your regression score was 72%. This lag variables will help you to capture the dynamics and further improve the regression. Okay, so now you are shifting this input variable by one time step from 0 to 1 and 2 time steps. Lag. So you are capturing not only the current value of the input, but trying to capture the value that corresponds to one time step before and 2 time steps before. Then you make a regression for these variables, this matrix. You just ignore the first 2 rows. From the third row, you can see that now Y3's dependency for X will be addressed by X3, that corresponds to the same time step, X2 that corresponds to a time step before, and X1 that corresponds to 2 time steps before. So you are capturing that information, dynamic information that is available in your data to regression. So this is for only one input variable I have shown. You can expand this. This is called column expansion. So this column expansion can be done to all the variables available. Okay, now instead of here, whatever the example we've seen, that is 2. Okay, instead of that, if you go to 5, this is only 2 variables, 2 lags. So let us say lag 3, lag 4, lag 5, but for all input variables, you can see what would happen. It is somewhat capturing better, but not. If you look at this region, it is okay, but still it is not captured very well. We need better, still better lag information. This lag information might not be enough. But if you look at the score, you can see that there is a 14-15% increase compared to 72%. We have 87%, right? Maybe instead of 5, you need to use more lags. Let us use 20. Right? Now you look at the graph. Look at this graph, and you can look at this graph. Using 20 lag informations, is capturing lots better compared to the original linear regression. So what we are doing here, instead of first case or this whatever graph you see, is when you have input regress, input regress versus output. But now you have lags of input. The different dynamic information is also captured. Instead of 20, you can also say, but still, if you look at this score, you can understand that it's already reached 99%. This is a very good regression score. Still improve. Oh, sorry. So, just give me a minute. I think it is because this is 20. Instead of 20, you can see 30. Now, we use 30 lakhs. You can see that 99.9% is your regression score. Correct. Now, you can keep increasing. You can say 30, you can say 50, you can say 100. So the score will keep on increasing, but the returns are diminishing, right? Like we had when it was 0, it was 72%, but when it was 5, there was an increase of about 15% in regression score. But when it was 20, the regression score did not increase more than 10%. Now, when it is from 20 to 30, the regression score has only increased from 99% to 99.9, 0.9% increase for 10 extra variables. There is a call that you can make based on the process or based on the accuracy that is required for the process. Say that this is the lag at which I'm going to stop. Because although it seems like computation might be not very expensive, but over time, when you do this multiple times or for multiple variables, it will cost you time. Correct. So computation is not really free. So you have to take a call based on the process, saying that, okay, this is where I'm going to stop. These are the number of lags that I'm going to capture. Of course, there are methods to do that. This is just a small example of that. See, like I said, because here we are considering 50 lag variables instead of 2 or instead of 30, and we are regressing all the equations to get the final result. You can see how sorry, I did not label this x and y. So this is the number of shift variables or lag variables that you're using for a given input variables. When it is 10, it's corresponding to almost 0.95 something. When it is 20, it is 0.99. When it is 30, it is 0.999. So you can see after 2025, it is not really improving. because there is no scope for improvement, right? So it is almost one, when it can be maximum, it can be 1. So if it is 99.9, if you keep increasing the number of lakhs, it will not improve by much. But every time you do the regression and calculate the prediction, it will have to solve a bigger matrix. So this is where you take a call and you say, okay, 20 or 25 is enough. 25. And you say, okay, this is representing my process correctly. If you look at the measured and predicted, they are in sync. So this is where you stop. You consider 25 lakhs for this particular regression, and you get the predictions. So this is for linear regression. If you are interested, I can explain how it happened in the code. And one important thing here is kind of data that you have taken. This can be further expanded, like here. These are all linear variables. Linear regression is when you interpret a linear relationship, but you can also interpret quadratic relationships beforehand. If you know, let us say this is a particular variable has a quadratic relationship. So you, instead of using x1, you can use x1 square as a separate variable. You will still get a regression coefficient for that. So that is how you can still expand the horizon of linear regression to do a nonlinear model. If you have a particular nonlinear model which you know beforehand, or even if you do not know, let us say you have pressure that is causing some changes in the quality. That pressure is having a square relationship along with the linear relationship. So instead of using just a linear column, you use another column in which your x is squared. That is your pressure, square of the pressure values you use in a different column. Okay, so that will capture the quadratic relationship. Coming to the scales, you saw that the variation in pressure is very small here. Variation in the quality is high. So that is also being captured here. So how that is being captured is, if you look at the gains of this process, or if you look at the individual plots, you will be able to see that the pressure is getting captured very well in this region because of the coefficients that it is bringing up. So that is why scaling is not a huge problem for linear regression. There are some classification methods or clustering methods in which scaling is of huge importance. Linear regression, you can do away with, scaling problem. Do you have any questions on this?
Participants, do you have any questions?
Not
No,
able to
sir.
see the chat window.
Chat window is open, sir. It is there, but no question is
Okay,
there
okay.
till now.
No questions. Okay, then. So if you want anything in particular, I can explain how we arrived at that, or any other methods that you might be interested. If it is there in the industry, I can explain. But otherwise, this is the sum and substance of how it is done in industries. So I'll just summarize. First thing is, we saw the introduction to ML and the stages of ML, the workflow. Then we have this model for naphtha splitter, and using linear regression, which is simple, we introduced lag variables to capture the dynamics. So from a simple linear regression, which still captured dynamics well, but not an extent that we would require. So introducing lag variables, you are able to capture very well. So this is a simple process. I just took, for example, this can be applied to the actual processes in refinery, etc. you will still get a very good model for this.
Sir, you can write your email ID in chat box. If any participants have question, then they can contact you or they can mail you. Are you? Hello?
I've,
Okay, yeah, yes, sir.
I've dropped in my email.
Yes, sir. So, any participants, if you have any question, then you can ask, or either you can mail to sir. Thank you, sir. Thank you
Okay.
for your resourceful speech. This informative speech is going to be very more productive for the diverse group of participants in the FDP platform. As sir explained what is machine learning, where we can use this machine learning, and sir explained difference between the traditional modeling and machine learning. Sir explained the method of least square method and how data are implemented using Python in a very beautiful way. Thank you once again, sir. Thank you so much. And thanks for accepting our invitation for FDP program. Thank you so much.
Thank you. Thank you for having me.
Thank you, sir.
Thank you. Bye, everyone.
Okay, bye. Participant, next session is start from 2 o'clock. That is validatory session. So everybody has to join this session. And for 5 minutes, if it is possible, then you can open your video switch on. So because we have to take photo of that. So please join validatory session at 2 o'clock sharp. It is compulsory for everyone to join. And feedback form will be available for session 14 in the chat box. Thank you so much, everyone.
ಇಲ್ಲ ಒಂದು ಫಂಕ್ಷನ್ ಇದೆ ಅದು ಮುಗಿಸ್ಕೊಂಡು ಲೇಟ್ ಆಗ್ತದೆ. ಹಲೋ ಹಲೋ
Yes, sir. Yes, sir. You're audible, sir.
ಜಾಯಿನ್ ಮೇಡಮ್.
Hello.
Sir?
Hello. Can you hear me?
Sir, can hear you?
Yes, yes. It's audible.
Yes.
Can we start, madam? Hello.
Sir, yes, sir. Actually, we are waiting for participants
Okay.
to
Okay. No
join.
issue. No, let
2
them
minutes,
let
sir,
them join.
please.
No, let them join. We will wait for their
Yes.
till they come back.
Yes, sir. Yes, sir.
Okay.
Good afternoon and welcome everyone to the valedictory session of Atal sponsored 1 week online faculty development program on data science and artificial intelligence in chemical engineering, recent trends and future outlook, organized by the Department of Chemical Engineering in association with IIC and IQAC MVJC. We have reached the end of this splendid program with eminent speakers sharing their knowledge and interacting with the participants. So I would like to express my sincere gratitude to all the participants, speakers, principals, sir, faculty members, the organizing committee, and chemical engineering department for their hard work, cooperation, and time. We are grateful to AICTE and AICTE Training and Learning Academy for sponsorship and knowledge exchange program. Faculty Development Program under Atal Initiative aims to train faculties and technicians not only in their respective disciplines, but also open the door to new technologies and highlight significance and application in the conventional curriculum. I'm sure this week-long program would have been a good opportunity for everyone to learn something new. So I would request the event coordinator, Dr. Manisha Balman, to summarize the Faculty Development Program.
A very good afternoon to everyone. Today at this moment, we are almost standing at the end of the program. And 5 days back, we inaugurated this program with a hope to make a holistic success of this program. Also a hope for many to begin their first stepping stone in the process of learning something new. Today, when we are almost at the end of this FDP program, I would like to conclude it was not just about fulfilling those hopes. It's been truly an experience for lifetime. Sessions after sessions, when we started proceeding further, our expectations were getting higher every day. Our demand was never constant in this process of learning something new. It was never an easy task for our speakers to dedicate themselves and coming up with the beautiful content to present in front of us every time. I truly thank our speakers for coming up with the beautiful content and for their sharing their expertise, and thank you for investing their precious time for making the FDP program a huge success. Our participants have always been enthusiastic and showed their great interest, not only to be a part of this program, but they devoted themselves as well. So to go beyond and by asking their individual queries and doubts, which truly goes with the true intent of such program. Thank you for being such enthusiast listener and being the unforgettable part of this program. Before we get into outcome of our sessions, I would like to thank our chief guest, Dr. Rabindra D. Guri, Professor IIT Bombay, sir, for the beautiful inaugurations and setting up the path for the journey of this program. He showed a clear directions in the process of learning data science and AI one and all. So, sir, deep dive into our sessions, which are delivered by our key speakers for this program. As we started our session 1 by Dr. Rabindra D. Guri, delivered a talk on digitalization, AI, ML, exciting opportunities in engineering. Sir have enlightened us about the emerging topics on sensor diversity, what is digitalization, importance of the IoT, and how does it impact significant opportunities of digitalization. Next session was delivered by Dr. Ashutosh Yadav, the Assistant Professor, Department of Chemical Engineering, IIT Jammu. He discussed about applications of machine learning for multi-phase reactors, and the professor has elaborated the revolutions of AI in chemical industries, imposed the importance of roles of statistics, and has well distinguished the difference between the traditional programming and machine learning. Even more, the basic of the machine learning was explained, and detailed note on the application of ML in petroleum refinery with case studies was well defined. So day one was ended with stress management session by Mr. Chandrakant Devra, Sahaja Yoga meditation. It was very interactive sessions. He stressed about the act of practicing healthy habits on a daily basis to attain better physical and mental health outcomes. We came across the various dimensions of wellness like physical, emotional, intellectual, etc. So effective stress management and the importance of meditation, which helps us to break the stress in our life so that we can be happier and more productive. So day 2 was commenced with the session 4 by Dr. M. Venkata Kittika, Associate Professor, Department of EEE, NIT Tiruchirappalli. Ma'am has delivered the lecture on role of AI in fuel cell management. The content of AI been elaborated in beautiful way that clear understanding have been created among each one of us. The informative speech is going to be more productive for this diverse group of this participant in this FDP platform. Efficiency and stability of the fuel cell, their different sources and customized controller in the fuel cell system was well explained. Ma'am have ignited curiosity to explore more on AI. So our next session was 5 was delivered by Dr. Anil Kumar, Senior Principal Scientist, CSIR, Fourth Paradigm Institute, Bangalore. Dr. Anil Kumar has discussed on the applications of data science in packets, protocols and attacks in cyberspace in the view of chemical process industry. So next session 3 was concluded with, day 3 was concluded with the session 6 by Dr. M. Nabil, Assistant Professor, Department of Chemical Engineering, IIT Tirupati. As sir has discussed about the views of the phases of AI in the chemical engineering, applications of ML, soft sensing, global and local modeling, and ore quality predictions, and the process monitoring. And after that, day 3 was commenced with the session 7 by Mr. Sanjay Venugopal, Senior Technologist, Eco Goa IA Technologist India Limited, Bangalore. Sir has started this session by giving the talk on data analytics techniques deployed in chemical process industries for advanced control and optimization since the 90s. He has discussed on the possible real problem arises in the process, and key solutions were discussed with the advanced technique and software demo. Even the advanced PC and model of predictive control actions and the performance were explained in detail. So next session was 8 of day 3 was delivered by Dr. Gyanendranath Mahapatra, Senior Scientist, CSIR 4th Paradigm Institute. And sir has spoke about the teaching ethics which had to be incorporated in AI course. Professor explained and gave details note about the technical challenges using big data day by day as chemical engineer and how we can overcome these challenges, even more the basic of machine learning, data engineers, Venn diagram also discussed by this by Dr. Gyanendranath Mahapatra. Session 9 of day 3 lecture was delivered by the Dr. Kunduri Aditya, Assistant Professor, Department of Computational Data Sciences, IISc, Bangalore. The content of this scientific computing has been elaborated in beautiful way that clear understanding has been created, and professor gave detailed note on turbulent flow simulations and brief introductions and parallel computing. So next session, the session 10 was delivered by Dr. Anand Gobind Rajan, and the Assistant Professor, Department of Chemical Engineering, IISc Bangalore, on Introduction to Boosting Algorithm in Machine Learning. Dr. Anand sir has spoke about the machine learning algorithm categorization, decision tree in machine learning, bootstrap, aggregations in machine learning, training and testing using k-fold validations, and gradient boosting in chemical engineering applications. So next session was 11th, was delivered by Mr. Ravi Kiran sir and the Senior Process Engineer, Grace Divisions Chemical India Private Limited, Chennai. Discussed on the digital twin application for steel refining process, and very nicely he discussed about the digital twin and secondary steel making process, casting process, and CFD process of latent processes and optimization technique. So later in the session 12, we had resource speaker Dr. Alka Kumari, scientist CSIR IICT Hyderabad, discussed on process design and simulation fundamentals and techniques. Ma'am has explained nicely the process and instrumentation diagram, process simulations using Aspen packages. So final day of our FDP started with session 13 by Mr. Ravi Kiran, Senior Process Engineer, Grace Division Chemical India Private Limited, Chennai, discussed on predicting right feed mix to control the product quality based on predictive analysis. So last session of our FDP was delivered by Mr. Sri Sandeep Adika, APC engineer, Ikogawa, IA technologist of India Limited, Bangalore. He emphasized on how AI and ML techniques can transfer dynamic modeling for advanced control and optimization in chemical process industry. So to end our valedictory, I am sure it has been beautiful path with a long journey for last 5 years where we can learn something new. We cleared our doubt and we never lost our hope. I am sure many of us have just initiated their learning path for data science and AI in their respective domain. For all of them, such program is definitely going to help to set a clear directions for themselves. Thank you.
Thank you very much, ma'am, for highlighting all the sessions and all the important parts. So now I would like to call Dr. P. Mahabaleshwarappa sir, Principal MVJC, to propose the vote of thanks.
Good afternoon to one and all connected to this, the August occasion of the virtual concluding ceremony of the 5 days of the faculty development program on the topic application of data science, AI and ML in the chemical engineering and recent trends and future outlook, which is organized by the Chemical Engineering Department of MVJ College of Engineering under AICT sponsored Atal FDP scheme, and it was inaugurated on 31st of August, and it went on very successfully and fruitfully and most productive way till on this day. Respected Honorable Chairman of our institution, Shri M.J. Balchandra sir, respected speakers of the August occasion, distinguished dignitaries participated in this Atal FDP, invited faculty members from the various premier institutions across the state, respected Vice Principal Madam, Dr. Brundayam, respected Professor Vaman B. Gudi, Registrar and Controller of Examination of our institution, respected Athira Ashokan, Professor and HOD of the Chemical Engineering Department, under a dedicated organizing team, HODs of the various departments, senior professors and the faculty members and the participants. Today, the 5 days of the Atal FDP faculty development program has successfully come to an end. On this great occasion, I am very happy to be a part of this concluding ceremony of this particular event. The ceremony was graced by honorable presence of many distinguished dignitaries, keynote speakers of the occasion. On the inaugural ceremony, it has been inaugurated by the Dr. Ravindra D. Gudi Professor in the Department of the Chemical Engineering, IIT Mumbai, followed by Dr. Ashutosh Yadav, Professor, Department of the Chemical Engineering, IIT Jammu. Also, during the continuous 5 days of the FDP, Mr. Ravi Kiran, Senior Process Engineer, Grace Division, Chemical India, Chennai, and Mr. Sri Sandeep Agadi, APC Engineer, IT Technologies India Limited, Bangalore. During these continuous 5 days of the various very important topics are addressed by the reputed professors, scientists, and eminent institutions from the eminent institutions. And they have invited the experts from the various chemical industries and research organizations. On the other hand, a very good number of faculty delegates are participated in our 5 days of the FDP. Further, it was very, very important aspect to note at this point, during this FDP that all the participants are very keenly and very actively involved and participated and witnessing the entire proceedings and the delivery of the various sessions and very important topics which has been delivered during this period of the 5 days of the FDP. Deliberations by various speakers focusing more on the role of AI and ML in fuel cell management, application of the ML for the multi-phase reactors, and how AI and ML techniques can be able to transfer dynamic modeling for advanced controls and optimization in the chemical process industries, and the various other trending technologies which are being practiced in the various chemical industries. I congratulate really and I thank all the faculty delegates and other participants for your positive and active participation in our 5-day FDP, and the entire organizing team for such an effective and the way of organizing in a fruitful manner and successful completion of the entire event. Due to everyone's effort and the participation has been at most unforgettable experience, and I hope everyone takes away some of the wonderful, useful memories in terms of earning the knowledge in various happening areas of the chemical domain, and the kind of professional experiences and organization skills that sets an exhibited by our organizing team. Everyone had an enjoyable experience in terms of gaining the knowledge, and not by just getting the pleasure in participating in this FDP, and also participating in fruitful discussions on the most happening areas. Finally, on behalf of the management and our institution and the organizing team of the Chemical Engineering Department on this great occasion, I would like to express my gratitude to all of you who have come together from the various parts of the state for participating in our 5-day FDP with all your good cooperation, which has enabled us to organize this highly successful and fruitful manner. On this occasion, again, I take this opportunity on behalf of the management, on behalf of the institution, particularly on behalf of the Chemical Engineering Department. I congratulate and I submit my sincere thanks to all the speakers and the resource persons and the organizing team. I convey my thanks to all the participants and the faculty delegates who have spared their valuable time for such a long time for 1 week continuously. They are all with us, with our institution, with the Department of the Chemical Engineering, to witness the entire proceedings and the delivery made by the various speakers of the occasion. Because of you only, we could able to manage and we could able to succeed in conducting this particular program in a more fruitful and productive manner. And lastly, I thank everyone who have participated and enjoyed this every moment of this, the Atal FDP. I take this the fine occasion for having invited me on this great occasion on the concluding part of the session of the Atal FDP. And I believe that, as the Manisha Wal has pointed out, rightly we have reached all the participants. And the expectations is too huge, expectations is too big. And looking at the greatest level of the expenditure, I believe that all the speakers, they have reached everyone in a rightly, and this kind of cooperation is needed for the future upcoming the programs of which is going to be organized by the Chemical Engineering Department of the MAJ College of Engineering. Once again, I thank everyone who are responsible for the successful completion of this Atal FDP of the Chemical Engineering Department of the MAJ College of Engineering. Thank you. Thank you, one and all.
Thank you very much, sir. So moving forward, any program will be incomplete without feedbacks. So I would request some of the participants to share their experience and highlights on this 1 week faculty development program. Participants are also most welcome to post their feedback in the chat box too. So let me call Dr. Chetan A. Nayak sir to give his feedback on the program.
Yes, yes.
Can we move? Okay, we can move on to Mr. Anthony Raj to give his feedback for the program.
Yes. Good afternoon to everyone. Can you hear me, ma'am?
Yes, yes.
Yes. Okay. Good afternoon to everyone. And then 14 days, 14 sessions was very good. Okay. First of all, the organizing committee was, the time consumption was very important. And then each and every session was very practical, and then live sessions, especially for yoga space assessment. No, the wellness through Akasha yoga space assessment is very live practical session. And then the role of AI, artificial intelligence, in fuel cell management is also very interactive sessions. And then all the 14 sessions also very interactive, and then live practical sessions, each and every session the practical live sessions, it is very important. And the background of CAC, the application of big data and AI was very interactive session, and then live very informative, and then very live sessions. We have a lot of information we have collected, and then we have to implement it our project also. And then product and quality based on predictive analysis also very informative. And then we have collected some informations. And then finally the last session was the opportunities in engineering. It's very good informative sessions for the students. And then nowadays a lot of problems we have faced to the current technologies and the industries. And then the last session was very impressed, and then we have collected some information. Okay. Thank you, ma'am. Thank you all. Yes.
Thank you very much, sir, for the valuable feedback.
Yes.
So we can move forward to Mrs. Karkuzali. I'm sorry if the pronunciation is not correct. So to give her feedback on the program, if ma'am is available.
Okay, very good afternoon to one and all. And it's my pleasure to express the feedback of this ARTL program for 5 days. And first of all, I thank the chairperson, Mr. M.J. Balachandar sir, the principal sir, Dr. P. Mahabaleshwarappa, and the vice principal ma'am, Dr. M. Brinda, for conducting such a wonderful and excellent program based on AI, especially on chemical engineering. And the speakers which on eminent resource persons having an expert lecture on different aspects in AI and machine language especially. So the topics were covering the topics on digitalization of AI and machine language, applications of different machine language, and the application of data science in particularly cyberspace. That is excellent. And the simulations techniques using ML, and also with the algorithm, especially that machine language algorithm discussed is excellent. And also there is a session with predictive analysis based on quality in product. That is also an useful session where we can identify the data collections, data models, and all those things. And the last section is on advanced controls and optimizing AI and machine language and machine learning. And all those things are with an excellent techniques which explained with the future outlook, how the future is framed with the chemical engineering. And being a non-computer science, that means I'm not in a chemical engineering base, but I very well know about what are all the data sets which are collected under chemical engineering. So once again, I thank you one and all, and I will try to have another program if you organize that. Thank you, sir. Thank you very much.
Thank you, ma'am.
Thank you very much, ma'am. So Dr. Chetan sir was facing some network issues, I think. So I'll hand over to him to give the feedback.
Yeah, thank you, madam. Actually, I would like to congratulate MUJ College of Engineering, especially Department of Chemical Engineering, who organized the data science and AI in chemical engineering and recent trends and future outlook. This is we are also looking in the same topic, but I'm very happy that you could gather very good speakers, very excellent speakers, especially Dr. Ravindra Gudi has guided you very well. And I congratulate each one of the team who one by one could continue the process. And as chemical engineering aspect, I suggest that this is one of the very important where we need to integrate between the new techniques like artificial intelligence as well as machine learning. And wish you all the best, madam. And I thank you for being the participant of this part. Thanks one and all. Thank you.
Thank you very much, sir. So I would like to request if anyone wants to voluntarily come and give an feedback from the participants. They are most welcome to do that. If anyone is facing any network issue or technical issue, they can even raise their hands to give the feedback. So thank you everyone for your amazing feedbacks for the program. So to commemorate the success of the program, I would request everyone to please switch on their cameras for a few minutes so we can capture a photo of all the participants. Thank you so much everyone for your cooperation. Now allow me to call Professor Atira Ashokan ma'am, Head of the Department Chemical Engineering, to propose the vote of thanks.
Am I audible?
Yes, ma'am.
Thank you, Asta. Good afternoon to one and all present here. Thank you for giving me an opportunity to extend my vote of thanks. I'm glad to have our guest of honor for valedictory session, Dr. P. Mahabhaleshwarappa sir, Principal MVJCE. We are honored by your presence, sir. It's a matter of great honor that our ACT sponsored Atal FDP on data science and artificial intelligence in chemical engineering, recent trends and future outlook, has completed its 5th day with great success. As we know, the main objective of ACT Training and Learning Academy is to impart quality education to the teaching and research community to support technical institutions in fostering research, innovation, entrepreneurship in the various emerging and thrust areas. First of all, I am thankful to ACT for accepting our proposal and giving us wonderful opportunity to conduct 5 days online FDP on data science and artificial intelligence in chemical engineering, recent trends and future outlook. On behalf of Department of Chemical Engineering, I would like to express my sincere gratitude to our respected management in VJCE for the constant support and facilitating us to conduct the 5-day FDP in a smooth manner. At the same time, I am thankful to Dr. Mahabhaleshwarappa sir, Principal MVJCE, for his continuous guidance and encouragement throughout the event. I would like to extend my gratitude to our beloved Vice Principal Ma'am, Dr. Brinda Ma'am, for her advice and continuous encouragement in making this FDP into reality. I would like to thank our COE sir, Professor Vaman B. Goody sir, for his tremendous support to make this program fruitful. On behalf of management of MVJCE and Department of Chemical Engineering, I express my gratitude to all the guest speakers of Atal FTP for your kind consideration, cooperation, and also to enlighten the teaching community with the informative sessions. It's our honor to have great personalities from academia and industries in the 5-day FDP. Many congratulations and my sincere gratitude to Dr. Manisha Bal Madam, our Atal FDP coordinator, for her sincere efforts and coordination in making this FDP a memorable success. I would also like to extend my thanks to all the faculty members of Chemical Engineering Department for their continuous support to make the program a grand success. I'm really thankful to all the participants for their active participation as well as their cooperation. It was really a learning experience for all of us. Last but not the least, I am thankful to IT Help Desk MBJCE for the technical support throughout the FDP. Thank you all.
Thank you very much, ma'am. Now, I would like to call Dr. Manisha Bal, ma'am, to conclude this program with the feedback link and relay the further instructions for assessment organized by the committee.
Thank you, Asta. It's my honor to have been asked to offer a vote of thanks on the occasion of AICTE Atal FDP program in our college MBJCE. I would like to share my hearty gratitude to AICTE for sponsoring our FDP program. And I take this opportunity to thank our management for their continuous support. And it's my immense pleasure to extend my sincere thanks to our principal, sir, Dr. Mahabaleshrappa, sir, for making himself available from his busy schedule. And thank you for your continuous support and engagement. And I take this opportunity to thank our respected Vice Principal, ma'am, Dr. M. Brinda, and for her constant guidance and support throughout the program. I would like to thank Controller of Examination, Professor Baman B. Guri, sir, for his coordinations and encouragement. On behalf of Management MBJCE and Department of Chemical Engineering, I would like to express my hearty gratitude to all the speakers for sharing their beautifully chosen topics with such illustrations and knowledge in our 5 days long faculty development program. The Honorable and respected Chief Guest, Dr. Ravindra D. Guri, it has been a tribute to host all the members and the audience of this program throughout these 5 days. I would like to express my gratitude to our HOD ma'am, Professor Atira Asokan, and for her continuous support and encouragement. And I would like to thank all my department faculty members for their kind cooperations and continuous support. I am thankful to all the participants for joining us here, even in this tough time, and thank you for all attending the sessions with a tremendous enthusiasm. I would like to thank to Astha and Manasa for managing the program in beautiful way. And I take this opportunity to thank IT Help Desk for continuous technical support for successful execution of this 5 days online FDP program. So last but not the least, I thank all the non-teaching staff for their cooperations during this journey. Once again, thank you all. So now I am sharing the link for a final feedback form and test link in the chat box. So as per AICTE, so attendance should be 80% and the test mark should be 60% to get the certificates. So I am sharing here in the chat box. So this link will be available till today 12 AM till midnight. So you can save this link and later you can give your response. I'm sharing this link also in the WhatsApp group. So please give the response in this link. So it will be available till 12 PM. Thank you.
Thank you very much, ma'am. Thank you for the opportunity also for the coordination opportunity. So with this, I hope everyone is able to access the links. So with this, please allow me to close the session. And again, thank you everyone for your time, cooperation, and also for being excellent participant and listener. So wish you all the very best. And with this, I guess we can conclude the session. Ma'am, can the participants leave the session? Okay, ma'am. Thank you. Thank you, everyone. Thank you very much.